Applied Biology organized by Eco Clubs Tihu College in collaboration with IQAC and Tihu College Science Forum. Respected President of Governing Body Tihu College, Dr. Narayan Chandra Sarma Sir, respected Principal of Tihu College, Dr. Suresh Bharati Sir, Honorable Guest of Honor, Professor Mohan Chandra Kalita Sir, Vice Chancellor of Krishna Guru Adhyatmik Vishwavidyalaya, Honorable Guest of Honor of this inaugural session, Professor Dhanapati Deka Sir, Vice Chancellor of Auditorium University, Honorable Distinguished Guest of this seminar, Professor Sahazuddin Ahmed Sir, Director of Global Innovation, Department of Biotechnology, Government of India, Honorable Keynote Speaker of this seminar, renowned scientist, Professor Prabodh Bora Sir, Director of Research, Assam Agricultural University, Honorable Invited Speaker, Professor Doypayong Bharadwaj Sir, Department of Biotechnology, Jawaharlal Nehru University, Honorable Invited Speaker, Professor Santaram Joshi Sir, Department of Biotechnology and Bioinformatics, Northeastern Hill University, Honorable Invited Speaker, Professor Pongo Setia Sir, Department of Life Sciences, Dibrugarh University, Honorable Principal of BDP College, Dr. Pradeep Das Sir, Honorable all the dignitaries present here, respected faculty members, respected researchers, academicians, respected participants, respected media persons, and their students, on behalf of Tihu College family, I, Rita Chaudhary, a faculty of Zoology Department, extend a warm and respectful welcome to all of you to this DBT-sponsored two-day national seminar on recent advances in applied biology. We are truly honored to have with us esteemed guests, a distinguished panel of speakers, researchers, and passionate students from different fields of sciences. We are really grateful to you all for your gracious presence in our college premises in this knowledge exploration event. Thank you all. Thank you everyone. We would like to begin this auspicious occasion with the lighting of a ceremonial lamp, which is a symbol of wisdom, knowledge, and enlightenment. May I request our respected President Sir, respected Principal Sir, and respected Vice Principal Sir to proceed for the lighting of the ceremonial lamp. Sir, please. I request our members to help in this process. Thank you, sir. Now we are going to sing our sixth anthem, and I request you all join us. Thanks, Secretary. Thank you all. May I take the privilege of inviting our respective dignitary to the dais. May I now humbly request our respective President of Governing Body, Dr. Narayan Sharma sir, to come on the dais. I request our members, Madhusmita Nath and Duri Kaiser, to help sir to come to the dais. Thank you, sir. May I request our respected principal, Dr. Chiren Borali sir, to come on the dais. May I now request our guest of honor, Honorable Vice Chancellor of Krishnaguru Adhyatmik Vishwavidyalaya, Professor Mohan Chandra Kalita sir, to come on the dais. Our members will help sir. Thank you, sir. May I now humbly request our guest of honor, Honorable Vice Chancellor of Auditorium University, Professor Anupati Deka sir, come on the dais. Thank you, Professor Deka sir. May I now take the privilege of inviting our distinguished guest, Professor Sahazuddin Ahmed sir, Director of Global Innovation, Directorate International Cooperation, Department of Biotechnology, Ministry of Science and Technology, Government of India. Thank you for Professor Sahabuddin sir. May I now humbly request our keynote speaker, renowned scientist, Professor Pramod Bora sir, Director of Research, Assam Agricultural University, to come on the dais. I would like to our Vice Principal, respected Ramakanta Goya sir, to come on the dais. Thank you, sir. May I now request you all to have a warm round of applause for our respected dignitaries present on the dais. Thank you, everyone. Now we will move to our felicitation program. First of all, we are going to felicitate our Honorable President of Governing Body Tihu College, Dr. Narayan Sharma sir, with a Phulam Gamusa, a sapling, and a memento of this DPT-sponsored today national seminar on research advances in applied biology. I request Rita Devi Madam, Department of Sanskrit, to felicitate our respected President sir. May I request our principal sir to felicitate our respected president, Dr. Sharma sir, with the memento of this national seminar. Thank you, sir. Thank you, madam. Now I request Pradismita Das, Department of Philosophy, to felicitate our respected principal, Dr. Philip Koralit sir, with a Pulam Kamusa and a sapling. We are truly honored to have with us our guest of honor, Honorable Vice Chancellor of Krishnaguru Adhyatmik Vishwavidyalaya, Professor Mohan Chandra Kollikar sir. I request Jury Kaisab, Department of Assamese, to felicitate our Honorable Professor Mohan Chandra Kollikar sir. May I request our respected President sir to felicitate Honorable Professor Kollikar sir with the memento of this DBT sponsored two-day national seminar. We are delighted to have with us our guest of honor, Honorable Vice Chancellor of Auditorium University, Professor Hanapati Dekar sir. I request Megha Chaudhary, Department of Political Science, to felicitate Honorable Professor Dekar sir. May I request our respected President sir to felicitate Honorable Professor Dekar sir with the memento of this national seminar. Thank you everyone. We all know that this seminar is sponsored by DBT and we are delighted to have among us Honorable Professor Sahazuddin Ahmed sir, eminent scientist and Director of Global Innovation, Directorate International Cooperation, Department of Biotechnology, Ministry of Science and Technology, Government of India, as a distinguished guest of this inaugural session. Sir, your presence has enriched this seminar and has added great value to our shared mission of scientific progress. I request Manusmita Nath to felicitate Honorable Professor Sahazuddin Ahmed sir. May I request our principal sir to felicitate Honorable Professor Mohammad Sahazuddin Ahmed sir with the memento of this DBT sponsored to the national seminar. We are going to felicitate the keynote speaker of this inaugural session, renowned scientist, Professor Prabodh Gora sir, Director of Research, Assam Agriculture University. Professor Gora sir has been engaged with different academic institutions as chairman, co-chairman, and members of different organizations and institutes like DBT, DST, ICMR, ICAR, and more. SAT has published more than 185 research publications, having 2,464 citations. SAT has visited several countries to attend international academic programs as resource person. Whatever I have mentioned about SAT is very less in comparison to SAT's contributions in the field of research and education. We are truly honored to have such an eminent scientist and noted academician in this knowledge exploration event. I request Dr. Kankana Deka, Department of Chemistry, to felicitate Honorable Professor Prabodh Boran sir. May I request our principal sir to felicitate Honorable Professor Prabodh Boran sir with the memento of this next seminar. We have our Vice Principal, respected Ramakanto, who are sir with us. I request Aparajita Bodua, Department of Assamese, to felicitate our Vice Principal, sir. I would like to thank our members for their cooperation. As we know that our state government has declared 2025 as the year of books in our state, so we would like to felicitate our esteemed guest with Hirok Bonti. Hirok Bonti is not only a book, but an emotion of every person related to Tihu College. It briefly includes the history of this institution and also the sacrifices of some great people to build this educational institute in Tihu area. I request our members to felicitate our respective dignitaries with a copy of this Hirok Bonti. Once again, I request our students to have a huge round of applause for our respected dignitaries as well as our all the members. Thank you. Thank you, everyone. The formal qualification program has completed here. This qualification program will be continued in our technical session 2. Now, I would like to invite our respected principal, Dr. Suresh Phoralik sir, to deliver the welcome address and also to share the vision behind this event. Sir.
Good morning, all of you. Respected President of Governing Body, Tihu College, Dr. Nananthan Mohammed. Respected Vice Chancellor, Bhartadev University, Dr. Professor Dhanapati Deka sir. Respected Vice Chancellor, Krishna Guru Adhyatmik University, Nohatra, Professor Mohan Chandra Kolita sir. Director DBT, Dr. Zazuddin Ahmed sir, respected Director Research Dr. Bora sir, Assam Agricultural University, respected Joshi sir, respected Dakpan sir, respected Principal NH College, respected Principal BBK College, esteemed research person, respected dignitaries, esteemed faculties, scholars coming from different universities and colleges, respected journalist friends, and my colleagues and beloved students of Tihu College. At the very outset, I welcome you all to this seminar entitled Recent Advances in Applied Biology, which has been sponsored by Department of Biotechnology, Government of India, and is being organized by the Eco Club Tihu College in collaboration with ITC and Science Forum of this institution. Tihu College stands out as one of the premier institutions of higher education in Lower Assam. Established way back on 4 July 1963 and having celebrated its Diamond Jubilee in February 2024, the college is nourishing itself with a rich intellectual heritage and academic ethos. Primarily located in a semi-urban atmosphere, it has been attracting the majority of the students from the outlying rural areas, ensuring them the best assistance and guidance, and thereby helping them to familiarize themselves with moral and civic responsibilities, besides the standardized academic curriculum. Committed as it is to society, the college has played a pivotal role in bringing about positive changes in society at large. The college gives a beautiful look with its eco-friendly campus engaged in a serene atmosphere conducive to the pursuit of knowledge. With the full-fledged streams of art, science, and commerce, Tihu College continues to add new feeders to its step. As a center for academic excellence and being committed to inspiring critical innovation, we have this time placed before our ardent participants the theme Recent Advances in Applied Biology. With a view to addressing current global challenges, including healthcare, environmental sustainability, and agricultural innovation. I hope that this seminar will be able to act as a platform to showcase the latest advanced research in applied biology. Let's hope that an engaging discussion on these issues related to the topic will take place in seminar that will influence the future of biological research and development. I express my sincere thanks and gratitude to the Department of Biotechnology, Government of India for its valuable sponsorship, which has made it possible for us to organize this platform. I am equally indebted to the faculties and scholars who have gathered in the college premises with their research paper for making the seminar a great success. I would like to conclude again by welcoming all to this great achievement academic event. Thank you all. Good morning.
Thank you, Principal Sir, for your wonderful welcome address. May I now humbly request our respected President Sir of Governing Body Tihu College to formally inaugurate this session of the DBT-sponsored 2-day national seminar on recent advances in applied biology.
Good morning. Respected Principal Chairman, Dr. Priya, Vice Principal Dr. Priya, Ramakanto Priya, other dignitaries of the time, Dr. Salam Ahmed, Scientist and Director, Global Innovative Director, International Cooperation, Dr. India, Professor Mohan Chandra Kolida, Vice Chancellor of Krishna Guru International Vishwavidyalaya, Professor Dhanapati Deka, Honorable Vice Chancellor of Auditorium University, Professor Prabodh Bora, Director of Research, Assam Agricultural University, a very good friend of mine since our college days, and he is a very leading academic in this region, doing lots of research and academic, very known person in the field of research. Other eminent speakers present for today's workshop, Professor Doipan Bharadwaj, ex-professor of Jawaharlal Nehru University, Delhi, and presently Professor of Shiksha, Nivedita University, Kolkata. Professor S.R. Joshi from Northeastern University, Shillong. Professor Pankaj Shettia from Dibrugarh University. Principal Pradeep Das from the Manikanta Faculty College. Kosik Deka from Nirmala College and other dignitaries present, my respected teachers of Tihu College and my dear student friends. Today is a very important day for us, for Tihu College, holding such a highly academic seminar in this college premises. It's very good and great news for all of us. Tihu College, in its glorious journey of 63 years of existence, have been producing thousands of very successful graduates and postgraduates from this institution. This is a college not only of this locality, it is a leading institution of the state of Assam. The Tihu College has been doing very excellent academic results continuously for several years in university examinations. And we have a very good team of dynamic teachers, a very enthusiastic group of students, and they have been tirelessly doing their job to achieve in the academic field. I would not like to hijack much of time from the eminent speakers because it's not my job to talk on the topic. But applied biology itself is a very important and upcoming subject without which you cannot think of research in many fields. Like I am a student of medical science and I know how important this applied biology is for the medical science, starting from the production of development of medicines, vaccines, gene therapy, and so on. This applied biology is also very essential in the field of agriculture, forensic science, environmental science, and many other such allied spheres. So I am sure this seminar today will show us new pathways for the development of applied biology, which will help in furthering our cause of betterment of humanity. I'd only like to quote one clause from the National Education Policy 2020, 7.2, how important the research has become in today's context. A robust ecosystem of research is perhaps more important than ever, with rapid changes occurring in the world today. For example, in the realm of climate change, population dynamics and management, biotechnology, and expanding digital marketplace, and the rise of machine learning and artificial intelligence. If India is to become a leader in this disparate area and truly achieve the potential of its vast talent pool to again become a leading knowledge society in the coming years and decades, the nation will require a significant expansion of its research capabilities and output across disciplines. Today, the criticality of research is more than ever before for the economic, intellectual, societal enhancement, and technological health and progress of the nation. 17.3. Despite this critical importance of research, the research and innovation investment in India is at the current time only 0.69% of GDP, as compared to 2.8% in the United States of America, 4.3% in Israel, and 4.2% in South Korea. So these two clauses very nicely reflect the importance of research in India if we want to be a global power in education, economic, in every field. But it has also shown that a lot of things, a lot of investment, more investment has to be there to achieve our goals. And we hope with the starting of the National Education Policy 2020, with the eventually by the government of India, we will see much more in the research activity in the colleges, in the universities, and everywhere. With these three words, I wish this workshop to be a grand success, and I declare the seminar on recent advances in applied biology open. Thank you very much.
Thank you, sir, for inaugurating the session. Thank you for your insight on this intellectual exploration event. It is now time to hear from our guest of honor. Before going to this, I have an important announcement. Respected dignitaries, participants, and dear students, our honorable chief guest of this inaugural session, Honorable Vice Chancellor of Guwahati University, Professor Nonigopal Mohanto sir, could not join us in this inaugural session because of some urgent official work in Raj Bhavan. Sir has conveyed his best wishes to us for the great success of this event. May I now humbly request our guest of honor, Honorable Vice Chancellor of Krishnaguru Adhyatmik Vishwavidyalaya Nohatra Barpeda, Professor Mohan Chandra Kalita sir, to deliver his speech. Sir, please.
Good morning, everybody. Respected Dr. Sharma, Principal, Dr. Parali, in the dais, Professor Deka, Ahmed, Dr. Bora, Dr. Bina, invited distinguished guests and other academics sitting in front of me, esteemed family member of this college and other faculties from different colleges joining here, program, and my dear students. So thank you so much for inviting me to share my views on a very important topic, and thus to ask me just to speak somewhat on secular data in very context, for example, apply the detailed concept of the explanation. What is coming from my end, during our college days, in our college days, I am given the college law university. About I had admission in some university, I was 6. But people somewhat negative. Because that's why. So ultimately, so go with me. Medical system from one then I started to, let's say, run. So now, the system is somewhat correct. Now, biological science, actually, whether it's in medical science, take it in different, whether in botany or life science, or take it around. Somewhat technical. I don't know in other areas. Medical is different from my experience. But now, present or recently, advancing biology like anything. Now people taking another way. Now people taking another way. And also I see now the chemistry school, physics school, mathematics school, also they just like to join with biological science research. You will see, I will say today a number of the posts in the. So anyway, the topic here is the recent advancements in applied biology. It's very important and very important topic. Thank you very much. It's a very much timely and critical topic. We stand at a pivotal moment where breakthroughs in biology conservation. In today's context, very important. Loss of biodiversity like anything, and it is a challenging issue, not only for Assam, all over India, not only for India, it is a global protection of biodiversity, conservation of biodiversity. The way we are using biodiversity. If you see, just on December 2022, encroachment of forest in India, around 7 lakh hectares in encroachment. My dear students, you can put it, it's a very important. In India, encroachment has been taken place around 7 lakh hectares. In Assam, if you see Assam, 50% encroachment here in Assam. 3.8 lakh hectares. 3.8 lakh hectares. That means around 50% forest area encroachment in Assam. Not in Assam. That is the situation. There also conservation and exploration. Preparation and resource. I am speaking something else things like exploration. Not to level exploration. The resource we have yet to be explored. What? Exploit. Exploit, not exploration. Environmental biotechnology, very, very important, is applied biology. Biotechnology, nothing else is applied biology. So we are facing lots of challenges. Not only encroachment, not only loss of biodiversity, environmental hazards and stresses, global warming, drought, pollution, and so many other things. So what we will do? We have to protect us, not only human, all life forms we have to protect. So therefore, actually,
our biology, our mindset should be like that only. So we can do something practical. Organic agriculture, these are all applied. Biofertilizer, thinking is okay, biofertilizer. I also work for my biofertilizer, but practically, a necessity of biofertilizer production, if we are playing it up the gap. Pesticides, a big hazard in the globe, not only here. So that's why people are working, trying to evolve some sort of biopesticides. But up to at present, we have actually not been able to meet up the gap by the biopesticides. So overall, the pesticides is a sort of major hazard for human beings. Major hazard for human beings. Not only human beings, other life forms. Bioinformatics, it's an interdisciplinary area, bioinformatics, where actually we have to integrate computer science, we have to integrate statistics, we have to integrate mathematics, so that we can actually analyze the data, whatever data we have from molecular biology, whatever data we have from genomics, proteomics, and so on. So then there's one very, very important area. Medicinal and aromatic plants. Medicinal and aromatic plants. Let me talk about medicinal and aromatic plants here. So, medicinal and aromatic plants, we are looking. That's what we are looking at. But what is the gut? But where is the gut? I also work on cancer, I also work on malaria, I also work on diabetes. What is the product? That's a big thing. So, this consistent stuff will be lots of state. And running towards global challenges like climate change and global warming, food security, drug discovery, and healthcare. These advancements are not just scientific achievements. They are pathways to sustainable agriculture, whether it's a biofertilizer or biopesticide, whatever it may be, organic agriculture. Ecological restoration, and improve human well-being. Particularly in regions like Assam, where indigenous forest is a part of the ecological policy. Indigenous forest system, every college, every don't get about indigenous forest system. I do not know whether you college they have or not. An enormous biodiversity both in and you start indigenous forest system is the big area. And particularly in Assam and Northeast, we have in Assam itself, we have more than 70 tribes and subtribes. In northern scale, we have more than 250 tribes and subtribes. So you see our interstate. Until you have to scientifically explore. But yet, without that particular gap. Nutrition is one biodiversity also. Our ecological biodiversity. Also, all over the globe, Arctic is hospital. Biodiversity is it. And they are very much fortunate. Then our economics, or not the country also. In India itself, we have 4 out of 36 global hotspots. India alone, we have 4 biodiversity hotspots. Globally, big city. Assam also globally big city. They are globally recognized our state also. What they are doing? We are losing our system. So that's a very important thing. What I think I must read like that thing. It's important to note that the world stands and on the table of biological evolution, and that will divide two circles. According to the move. Health, energy, and environment. It needs to mention that landscape of modern biology, not ideal biology, landscape of modern biology and biotechnology or applied biology, whatever it may be, and other science subjects changing with the passage of time. Now, at present, modern biology is difficult to accept. Without integration of physics, without integration of chemistry, without extra mathematics and without putting extra with it, artificial intelligence. So very much important. So that way actually, never you neglect biology. Come forward, chemistry, for mathematics, for even local electronics, so that you can contribute something for the development of the modern biology. Over the last few decades, biology has transformed to a productive and bioengineering. Productive and bioengineering. The cell is driven by genetic microbiology. Now the students in this state, they very happy. Totally university or and then like this, they learn it. But they say, like say, I work on genetic engineering, molecular biology. Very important. From decoding the human genome to anything 10 years, decoding the human genome from anything 10 years, our ability to understand and look at life at a molecular level is very hard to see. Even the scope, deep ability, deep, what ability, we can, according to only if we have to improve our students' evolution. Then, the first thing, synthetic biology. Synthetic biology, biology itself is synthetic biology. You see, vaccine development, biofuel development, eco-friendly materials, nanobiomolecules, nanobiotechnology, and so on. What happens to keep the medicine and engineering in this context? First one point coming to my mind. That actually I know it. I am happy to mention because many of you might be knowing. Everybody mentioned the name of Dr. Rupul Mao. Dr. Rupul Mao, who is working hardcore research on genetic theory for cancer drug development. For cancer drug development in Harvard Medical School. He has achieved significantly and second part, there has been a global. His work has been a global work from his. Just coming to the point. He had also collaboration. He also worked with David Becker. With one David Becker. He was also a chemistry. Who received Nobel Prize in chemistry? David Becker last year in 2004 received Nobel Prize in chemistry. He was a man of chemistry, but he was what? Biology. He was from biology, what? Cancer drug development. 2024. Dr. Rupul Mao, I have a postdoc to him, so that way I know him. Dr. Rupul Mao is considered as a potential Nobel. In this, he is considered. He may be considered a potential Nobel. He was an agent who had become proud, happy to just mention. Rupul Mao, he was from the Department of Chemistry. He completed a master degree in chemistry in 2000. And why he got in chemistry? Sometimes he came to a department. Then he on something like biology and all. And our department also not the level. But he knows but like somehow it's like what is this? I like to have this. And he completed degree from he is from Assam, one is in Alpha area, Tacoba. That's the root of the blood. So when you see one boy from Assam, any foreigner, one book very popular, Muru et al. Very popular, Muru et al. One Piakiman Port, one Durito, came on the Harvard Medical Center, Nobel Congress. Maybe only people from Assam, I don't know the name, who are working, but I know him because I have a postdoc with him. Now, applied biology and biotechnology is no longer confined to level. That is not the problem. It should not be confined to level 2. Come to PhD or PhD or get over. Even at the one who is developed, that's something you can develop. That will be your future. Otherwise, ये जो आप ये so monoculture sector, monoculture sector, but now agriculture is neglected nowadays. Agriculture is neglected somehow. Only coastal down more like agriculture is lower than agriculture is one. Say mushroom cultivation. Mushroom cultivation. Why not get this to on mushroom cultivation side? Because certificate course very much important certificate course. As per anything, mushroom cultivation. 10 activity. Why is it not 10 activity? Not that difficult also to get. Professor, maybe we are from the back to everything here. It will start to one, 10 people come to the laboratory. Political, what is political? All powers of it was matter. All powers, why in the body market, ask them where from the town. Come from. Only they can make amount of Hagoria, other from the political. Indigenous ornamental trees. Because of the diversity, indigenous ornamental trees represent the hospital or indigenous ornamental trees. Why you cannot ornamental trees? Why you can? That's also should be a certificate course. Honeybee, epicasa. If you need expert, I can send one expert also, very prominent expert. So honeybee, one plus, maybe on certificate course. Just let me take you 1 minute. The state horticulture college, adjacent to state of the horticulture college, just immediately north of where located nearby, very much supported to it. Why not we can have one among the state horticulture college? Because they have the one big unit. I used to go somewhere, they have one big unit of master practice. They have one big unit of floating agriculture. Why is it floating agriculture? So we can have, and you can also have one MOE. Also, what you can do, actually, our university initiative, we have one higher educational hub, 21 colleges, Inaugural also there, 21 colleges there. So we are moving now. So that jointly, before college, we can do something. That's the meetup and anything 2020. So Tihu college also, for one college will complain, but Tihu college also with nearby one or two colleges. Now the initiative they can take like healthcare technology, mRNA vaccine, regenerative medicine, chemical therapy, and AI assisted drug discovery. Yeah, doctor now there is a global level. What is the for cancer development? He is a man of the body. Now in identical biology. Now what is the artificial intelligence induced drug development. Artificial induced drug development. That is protein. What? Cancer development. That is for medicinal transformation. It will get. So all applied. So sustainable environment, very important. Sustainable already told you with the concept of biodiversity. What is this? Seven things to maintain. Biointegration. Also is unprecedented. So that we can something like political ecosystem, bioplastic development. One of my students, now that he is in Bombay, in Reliance, worked on biorefinery, on algal refinery. Now he has both. What is working now? On bioplastic. Bioplastic development, carbon capturing microbes, biological system, waste and quite good at all, has been in the flowers. Agro-industry, like they promote the ecology, giving them the same processes, organic waste, and bio-waste. Yes, sir, they are 14. Why on like bamboo-based? Why cannot bamboo-based cannot also leak? All over the globe, there is a one unit. Here in Assam, ultimately, our Prime Minister of India, Inaugural. There is also a supply driver. Development. Also, one can do development of indigenous medicinal and garbage. Why can develop the medicinal and garbage? We can, so that we can supply to the Ayurvedic industry. That's the so therefore, actually, those are all applied things on where also generate fund, their money, also we are motivated them to audience to adopt. So why you cannot have one can agriculture garden, one mini garden of agriculture, so that we can motivate them. One marketing unit, why they are not so that we can motivate them. Chemical sir, why is it not chemical sir? Any Buddha gold. Now we don't want to say any chemical sir. Obviously, not a technical side. There is the chemical side, technical side. No more. Technical side, technical side, very important. We are also technical. We are also technical. And that's what we will do. So, that's what we do. It's a very important thing. Is there not only college again? Why cannot go? Because the school level also what gets the level will start very very school. And in some schools, laboratory structure of some level is there. Not the basic. That's the thing that very important. Micropress development, why two collectors, micropress development, one micropress of unit. It's okay. Where does the law? There is not. Practically, we should come to equalizer. One micropress or mini press. You can hear of the level for them of sorry, big area. Only experimental area also one must be you can know. So actually comes to my mind. Not the other way. I raise the thing like supply value to guided policy. So the problems try to overcome for a healthier, greener, and more peaceful. So I took both ways, according to one couple of times. And that is the time you get from my caring idea, my good ways there, about delivering the about partisan they will share. Fostering collaboration is very important collaboration. And inspiring our youth to be called bearer of this new and together. Inspiring our youth to spread to be the cause bearer of this new and together of applied. Thank you very much. Thank you.
Thank you, Professor Panikar sir, for your well-explained speech. Your insights were thought-provoking and added immense value to our event. Now, may I humbly request our guest of honor, Honorable Vice Chancellor of Auditorium University, Bordali, Professor Dhanapati Dekha sir, to deliver his speech.
Prabhat, good morning. Honorable Chairperson of the governing body of this college, Dr. Sharma, respected principal of this college, Dr. Suresh Bharali, Honorable Vice Chancellor of Inaugural University, Professor Mohan Chandra Borita, distinguished scientist from DBT, Dr. Sahaduddin Ahmed, keynote speaker of this session, Professor Prabhu Bora, invited speaker, invited research person, esteemed faculty members, vice principal of the college, and principal of different colleges gathered here, delegates, research scholars, Thanks for media and the participants and my dear beloved students. Really, give me very immense pleasure because to this very August gathering, very important sessions, I have been invited to give some speech standing in front of you. This is a 2 days seminar sponsored by DBT, Recent Advances in Applied Value, which is very important to this context. I extend my warm welcome to you who have gathered here, delivered on the emerging frontier of biological sciences. As I know, this Tihu College, which was established in 4th of July 1963, some of the luminaries, personalities, this is their big thought. তেওঁলোকে ভাবিছিলে টিহু অঞ্চলত এখন উচ্চ শিক্ষানুষ্ঠান তেওঁলোকে প্ৰতিষ্ঠা কৰিব যাতে ইয়াৰ ল'ৰা ছোৱালীখিনি আহি তাত পঢ়িব পাৰে আৰু শিক্ষাৰ ক্ষেত্ৰত এইটো গোটেই টিহু অঞ্চলটো আগবাঢ়ি যায়। আজি তোমালোকে ছাত্ৰসকলক উদ্দেশ্য কৰিছো তোমালোকে এখন এনেকুৱা ভাল শিক্ষানুষ্ঠান পঢ়িবৰ কাৰণে সুবিধা পোৱাৰ মূলতে আছে সেই সকল মহান পুৰুষৰ যিসকলে আজি চেক্ৰিফাইচ কৰি থৈ গৈছে বহুত কষ্ট কৰিছে এখন মহাবিদ্যালয় স্থাপন কৰাৰ। আজি যিটো প্ৰেক্ষাগৃহত আমি উপস্থিত আছো কেচি দাস মেমৰিয়েল প্ৰেক্ষাগৃহ, মই জানিবলৈ পাইছো কেচি দাস মেমৰিয়েল প্ৰেক্ষাগৃহটো তেখেতে সেই কেচি দাস তেখেতে প্ৰথম গভৰ্ণিং বডি চেয়াৰপাৰ্চন আছিলে। তেখেতে ইমেন্সলি এখন কলেজ ডেভেলপ হোৱাত যথেষ্ট সহায় কৰিছিলে। মই সকলো তেখেতক প্ৰমুখ্যে সকলো এই মহান পুৰুষসকলক মই মোৰ প্ৰণাম ধন্যবাদ জনাইছো। Dear students, before I go in my short speech, I would like to say one thing. ছাত্ৰসকল তোমালোকে আইনষ্টাইনৰ কথা জানানে? আইনষ্টাইনৰ কথা জানা সবে? আইনষ্টাইনৰ কথা শুনিছা? আইনষ্টাইনে ৰিলেটিভিটিৰ ওপৰত বিভিন্ন ঠাইত বক্তৃতা দিব মাতে। আমাৰ নিচিনাকে বক্তৃতা দিব আহে, মানুহে বক্তৃতা শুনে, বুজি পাইছে না? তেওঁ যেতিয়া বক্তৃতা দিয়ে তেওঁৰ লগত অহা ড্ৰাইভাৰটো পাছফালে বহি থাকে, তেওঁ আইনষ্টাইনৰ বক্তৃতাত তেওঁ মুখস্থ হৈ গৈছে কি ক'ব লাগে কি নাই। এদিনাখন আইনষ্টাইন এনেকুৱা এটা ঠাইত গ'ল যে প্ৰথম তেওঁ মাতিছে আৰু কোনো তেওঁক চিনি নাপায়। আইনষ্টাইনে ড্ৰাইভাৰটো ক'লে এটা কথা যে মোৰ আজি বিৰাট গাটো বেয়া, মই একো কথা ক'ব নোৱাৰো, তই মানুহক দেখা দি আহিবি। ড্ৰাইভাৰটো কৈছে ছাৰ আপুনি চিন্তা নকৰিব, মোৰ চিন্তা আপুনি বহি থাকক, মই লেকচাৰটো দি আহিম, আপোনাক এইটো কোনো চিনি নাপায়। ড্ৰাইভাৰটোকে আইনষ্টাইন বুলি লৈ আহিলে ওপৰত, তেওঁ সুন্দৰকৈ লেকচাৰটো পুৰা মুখস্থ, তেওঁ মুখস্থ লেকচাৰটো গৈ তেওঁ দি আছে। দি থাকোঁতে অডিয়েন্সৰ পৰা এজনে এনেকুৱা এটা ক্ৰিটিকেল কুৱেশ্যন সুধি দিলে ৰিলেটিভিটিৰ ওপৰত, ড্ৰাইভাৰটোকে কি কৰিব এতিয়া, কেনেকৈ এনচাৰ কৰিব? তেওঁ কৈছে এইটো একদম সহজ কুৱেশ্যন, এনচাৰ দিব, মই এনচাৰ দিব নালাগে, ড্ৰাইভাৰটো মাতক, তেওঁ এনচাৰ দিব পাৰিম। ঠিক তেনেকৈ মই কথাখিনি কিয় আছো, আজি মই যিখিনি কথা ক'ব বিচাৰিছো, মোৰ সন্মুখত বহি আছে ডিপিটি চাইণ্টিষ্টসকল, মোৰ সন্মুখত বহি আছে প্ৰফেচাৰ মোহন কলিতা, এজন বিশেষজ্ঞ বায়'টেকনলজিষ্ট, প্ৰভুত বৰা তেখেত বহি আছে, তাৰ মই বায়'টেকনলজিৰ দুই এষাৰ কম বুলি ভাবিছো। Dear students, friends and my participant, if you see the 21st century, this has undergone a paradigm shift. Whatever we thought, whatever we learned regarding the biology, understanding life processes, this has changed today. It has been converted to the applied biology. Why? Because this is translating to knowledge into solution. What type of solutions applied biology can give us? Solution for food security. Very important. Our population is increasing. Our Mother Earth is unable to bearing the capacity. Our food is very synchronizing. Our India is blessed. We have a lot of food in that sense. But it will also be due to the highest amount of populations in India. It will be very threat in future. So applied biology are able to give the solution for food security. Very important. Human health, another very big area in the human health. I come some elaborately I tell you human health, how human health applied biology has helped us. Then environmental sustainability. see the environment, climatic change, other pollution. So how this applied biology is very, very important. And industrial goal. I would like to give my sincere thanks to DBT because they have given this seminar, they have sanctioned this seminar to this Lower Assam of India so that our students will be enlightened, our participants will be enlightened about the recent development about today's this applied biology. I already told you, our Professor Kolita also told about the agriculture and food security. You see how agriculture and food security they are very, very important nowadays. Health and medicine I already mentioned, environmental sustainability and also industrial application. If you see, especially agriculture and food security, what is that? This agriculture, it has faces unprecedented challenges. What type of challenges? Climate change. How climate change is a problem for security? How climate change is a problem for agricultural production? Dear students, now due to the climate change, where we grow, where the fertile soil we grow the rice or wheat, that might be have to shift to other places because climate temperature is increasing. Every crops needs some minimum temperature. If that temperature exceeds, that temperature may not support the growth of the any our food crop. So we have to shift it. How we shift it? Because we have to shift to maybe some unfertile soil. Big challenge, climate change. Soil degradation also. Water scarcity is a big problem now, and a rapidly growing population. These are the challenges we have for agriculture and food security. So in case of, I already gene editing, Professor Kolita also told, gene editing, perhaps you know one thing, cut and paste, where some files from the computer you have to cut and put in some other file. You know this? Cut and paste. Similarly, now it is possible cut and paste of the genes. You see, in the science applied biology developed so nicely. In the gene also, our deputy scientists, they will, I think certainly I will explain. Gene also it is possible, gene can cut and another gene can put in there. What happens? How it will be possible? Because CRISPR-Cas9, this is like a cut and paste tool for DNA. Our DNA, which depict our character, depict our trait, that DNA gene is embedded in the DNA, that gene can be cut. And another gene from that can be also put there. What will be benefit of us if we think, suppose I can say Nahor tree. Nahor tree, perhaps you know Nahor tree. I did work on the Nahor tree, so I can tell you. In the Nahor tree, the oil content, because I work on the biofuels, in the Nahor tree, what happens? In the Nahor tree, there is a Nahor tree, highest amount of oil is available, 75% oil is available in the Nahor tree seed. But, sorry to say, to growing Nahor tree, it takes more time, minimum 6 years gestation period. So it will be not benefit. But, if some this recombinant DNA technology or genetic engineering, if some trait gene, we can find out some traits which are very fast growth, that can be put in the Nahor tree gene, and this Nahor tree will go fast and it will get a big source for oil, whatever oil process is there. From white oil, we can get a big source. Likewise, we can have to manage the cut and paste technology, whatever is possible due to the applied biology today. This is CRISPR-Cas9. And another important thing, whatever I like to mention you, this important, I would say, contribution of this applied biology is marker-assisted breeding and transgenic technology. So transgenic technology, more or less, whatever I told likewise, marker breeding. So marker can tell us which we have to select it for breeding, which plant we have to select it for growing. So this is the technology, this is the possible now only for the whatever I told about the applied biology problem. So this achieving food and nutritional security under the pressure of climate change and population growth is possible only the applied biology solution. Bioremediation already Professor Kolita told this bioremediation, this is important. Bioremediation is nothing but use of living organism. We have a lot of living organisms there. That living organism, if we use suppose microbes, fungus, bacteria, plant to detoxify our polluted environment. Our polluted environment is there. If some microorganism is there, that can improve our polluted environment. Professor Kolita and myself also work in one DBT sponsored project. That is the microalgae. That microalgae would use and in an industrial area where industrial pollutant can be removed by the microalgae. Like bioremediation, the important tools. Whatever is a very important tools for all our new scientists and all our newcomers. You should know bioremediation. Then engineer microbial strains. That strains. So that strain also been one of the tools for pollutant, specific pollutant degradation. Conservation biology. I already told you. The conservation biology, why it is important? Because of the conservation biology due to the temperature, with the climatic change, some plant it is unable to exist in the ecosystem. So that can be this can be habitat loss also be possible. Invasive species and biodiversity decline might be there. To conserve it, what happens? This molecular genetics, genomics, single cell genomics is a big science now. Single cell genomics study. Suppose I have one problem in my body, they are unable to study. But by bioinformatics or study of single cell genomics, it is possible to take what type of disease you have. What type of, I would say, you would need the medicine. All is possible now. This is possible. So, this DNA barcoding and environmental DNA analysis, these are all possible. Then, regenerative medicine, true healing and recovery is possible by regenerative medicine. Dear students, now the time for artificial intelligence. Artificial कृत्रिम बुद्धिमत्ता. तुम्हाला काय कृत्रिम बुद्धिमत्ता विषय जाणार ना? तुझे कृत्रिम बुद्धिमत्ता कुणीच नाही artificial intelligence. कुणीच नाही. अरे मागच्या तुम्हाला काय प्रश्न घेतली কথা বলতে স্যার इंटेलिजेंट आर्टिफिशियल इंटेलिजेंस विकल्प कुणीच नाही तुम्हाला ते. এতিয়া ভাল লাগিছে কুণিছে বুলি কোৱা কাৰণে আৰ্টিফিশিয়াল ইন্টেলিজেন্স মই এজন সায়েন্টিস্ট শুনিছিলো আমেৰিকান সায়েন্টিস্ট আহিছিল আমাৰ তাত মই শুনিছো আৰ্টিফিশিয়াল ইন্টেলিজেন্স আসলে বলছো কি ইমান হৈছে আৰ্টিফিশিয়াল ইন্টেলিজেন্স তো আমাক সিম্পল ভাষাত মই একদম সিম্পল ভাষাত বুজাই দিও নহলে আমাৰ এই ঢুকি নাপাব আমাৰ কম্পিউটাৰে তেওঁ কৈছিলে হিউম্যান ব্ৰেইন আছে আটাইতকৈ ৰিচ আৰ্টিফিশিয়াল কিয় হিউম্যান ব্ৰেইনটো আমাৰ হিউম্যান ব্ৰেইনত কম্পিউটাৰ নিচিনা CPU আছে নাই CPU সেন্ট্রাল প্রসেসিং ইউনিট মই যদি কথা কৈ থাকিব লাগে সেন্ট্রাল প্রসেসিং ইউনিটে মোক কৈছে কথা কৈ থাকা GPU আছে CPU and GPU graphics processing unit graphic processing unit means I can identify different type of colors different type of peoples different type of videos audios earlier আমি কি কৰিছিলো আগতে আমি সেন্ট্রাল প্রসেসিং ইউনিটৰ দ্বাৰা আমি কম্পিউটাৰত টাইপিং কৰি দিও কৰি থাকো টাইপিং কৰো কিবা কৰো ৰিজাল্ট পাও ঠিক তেনেকে আমি জিপিইউ দ্বাৰা আমি ভিডিও চাইছো আমি ফটোগ্ৰাফ চাইছো সাইন্টিস্টে এতিয়া দুটা লগ কৰি দিছে সিপিইউ এণ্ড জিপিইউ আৰু লগ কৰি তাত ইমান প্ৰগ্ৰামিং কৰিছে এইটোৰ মই ক'ব নালাগে তোমালে বুজি পাইছা ইমান প্ৰগ্ৰামিং কৰিছে ইট ইজ ভেৰি ফাষ্ট আৰু এতিয়া সেই কৃত্ৰিম বুদ্ধিমত্তা আছে ইয়াৰ ফলত সেই কৃত্ৰিম বুদ্ধিমত্তা আৰ্টিফিশিয়াল ইন্টেলিজেন্স আছে এই আৰ্টিফিশিয়াল ইন্টেলিজেন্সক কয় জেনাৰেটিভ এআই মিন্স ইয়াৰ ইমান কেপাচিটি যিকোনো বিষয় এটা যিমান ৰিসোৰ্স থাকে সবখিনি সেকেন্ডত এক্সট্ৰাক্ট কৰিব পাৰে আৰু এক্সট্ৰাক্ট কৰি হিউম্যানক যিখিনি লাগে মই যদি ভাবো মই এনেকুৱাকে লাগে তেওঁ আনিব পাৰে গতিকে আৰ্টিফিশিয়াল ইন্টেলিজেন্স is become so important nowadays any subject তেওঁলোকে হিউজ ডাটা আনিব পাৰে আজি যদি বায়োলজিৰ কথা কওঁ, বায়োলজি আমাৰ হিউজ ডাটা আছে, যেনেকৈ হিউজ ডাটা আছে বায়োলজি, আমাৰ বিভিন্ন ক্ষেত্ৰত বায়ো ইনফৰমেটিক্সৰ ডাটা আছে, বায়োলজি স্পেচিছৰ ডাটা আছে, টেক্সনমি ডাটা আছে। এই সকলোবিলাক ছেকেণ্ডতে তেওঁলোকে ৰিড কৰিব পাৰে আৰু ৰিড কৰি আমাৰ প্ৰয়োজন সাপেক্ষে আমাক দিব পাৰে। মই কিছু কথা ক'লোৱে আৰু বৰ বেছি নাকাওঁ, কিন্তু আমাৰ এই কথাটো আছে আৰ্টিফিচিয়েল ইন্টেলিজেন্স বেছিকৈ ইউজ কৰাৰ ফলত আমাৰ কিছুমান প্ৰব্লেম আহিব পাৰে, যেনেকৈ ইথিকেল কনচিডাৰেশ্যন, ইথিকেলৰ কথা আহিব পাৰে, ডাটাবিলাক আমি ৰিচাৰ্চ কৰি থৈ দিব নোৱাৰো, তাৰ পৰা প্ৰাইভেচিৰ ওপৰত বহুত ডাঙৰ কথা আমাৰ আহিব পাৰে, আৰু ইকুইটেবল এক্সেছ যেটো হয় তাৰ কাৰণে কেনেকুৱা নিগেটিভ আহিব, সেইবিলাক কথা আমি এতিয়াও জানিবৰ কাৰণে বহুত দিন আছে। AI powered drones বা sensor monitoring plane health, it's enable early detection of pest and disease. মইতো বহুখিনি কথা শুনোকে তোমালোকক ক'লো, আপোনালোকক সকলোৱে ক'লো, যেনেকৈ কেনেকৈ এপ্লাইড বায়োলজি AI তথা এপ্লাইড বায়োলজি গুৰুত্বটো বৰ্তমান সময়ত। এতিয়া মই আৰু এটা দিশত অলপ সৰু কথা কৈ পেলাই মই সামৰণি মাৰিম। How applied biology and social science are doing. এনেকুৱা নহয় যে এপ্লাইড বায়োলজি আমি এপ্লাই কৰিছো, বহুত কিবা কানি পাইছো। ভ্যাকচিনৰ কথা আপোনাক ক'ব বিচাৰো। Regarding the vaccines that have been during the COVID-19, আমাৰ কিন্তু ভ্যাকচিন ছিল, কোভ্যাক্সিন আহিছিলে। ইমিডিয়েট আমাৰ বায়োলজি ইমান ডেভেলপ হৈছে, NIV বা ICMR তেওঁলোকে লগ লাগি ইমান সোনকালে আমাক এটা ভ্যাকচিন ওলাই দিলে against the COVID-19. আমাৰ ইমান পপুলেশ্যন, যদি আমি ভ্যাকচিন বাহিৰৰ পৰা কিনিব লাগিলে হয়, আমেৰিকাৰ পৰা কিনিব লাগিলে হয়, বেলেগ কাণ্ট্ৰিৰ পৰা কিনিব লাগিলে হয়, কিমান আমাৰ ৰিচাৰ্চ গ'ল হ'লে। কিন্তু আমাৰ সাইন্টিষ্টসকলে এনেকুৱা এটা ভ্যাকচিন ওলাই দিয়ে, কোভ্যাক্সিন। বহুতে সেই সময়ত কোভ্যাক্সিন ল'বলৈ বিচৰা নাছিলে, বহুত ধৰণৰ কথা ওলাইছিল, যিবিলাক কোভ্যাক্সিন ল'লে হ'ব, হয়তো আমাৰ গোটেই জেনেৰেশ্যন ধ্বংস হৈ যাব, হয়তো আমি বহুত বেমাৰত ভুগিম। কিন্তু ডিয়াৰ ফ্ৰেণ্ডছ, see the impact of covaxin, how covaxin has helped us to recover a very dreaded virus attack, COVID-19. Even I can say proudly that covaxin, India has discovered this covaxin in India and distributed around 90 to 100 countries. This is the good things that BBT has done and all the biological group has done. Bina poisa প্ৰায় 100খন কাণ্ট্ৰিক আমি দিছো, সকলো বাছি থাকক, one earth, one nation, one, so আমি সকলোৱে আমি একেলগে one nation, one earth, one health, এই আমাৰ যিটো আমাৰ মূল প্ৰিন্সিপল ইণ্ডিয়ান গভৰ্ণমেণ্টৰ বহুত কাণ্ট্ৰিক আমি বিলাই দিছো, আমি নিজেও বাছিছো, আনকো বিলাই দিছো। এনেকুৱা এচিভমেণ্ট বৰ্তমান বায়োটেকনলজি এৰিয়াত হৈছে, এনেকুৱা এচিভমেণ্ট হৈছে আমাৰ বায়োটেকনলজি ষ্টাৰ্টআপ বায়োটেকনলজি। মই যিটো গম পাইছো প্ৰায় 10,000 and above ষ্টাৰ্টআপ আৰম্ভ হৈছে, বহুত বায়োটেকনলজি বায়োটেকৰ বহুত ডাঙৰ ডাঙৰ কোম্পানী এষ্টাব্লিছ হৈছে ইণ্ডিয়াত। এনেকুৱাকৈ আগবাঢ়ি গৈছে ইণ্ডিয়া এতিয়া বায়োটেকৰ কাৰণে ফলোৱাৰ্ছ নহয়, দে আৰ প্ৰডিউচাৰ। এভৰি biotech producer, India is a biotech producer, biotech hub, become a biotech hub. All these big companies used to come to India to produce their product because India's generation will say, tomorrow generation, hey generation can আমি ভালকৈ biotechnology উপর আমি পরীক্ষণ করব পারিছো। How applied biology and social science are linked? মই এখানে বলছো যেতিয়া কোভ্যাক্সিন ওলাল তার যদি বিরিড হৈছিল, সেইবিলাক সম্ভৱ হৈছিল only possible only change the human behavior, social acceptance, policy framework, and cultural practices. That was possible only by the humanities and social science department. So we are interlinked. We cannot think and we should not think that science is different from humanities. Now NEP 2020, we are going with the NEP 2020. Here, this is very, very importantly, it was emphasized on multidisciplinary courses. Why? Because of this all this thing, multidisciplinary. So those who are the emerging scientists, those who have come here, presently at record, I just have a message to them. Go for a project, multidisciplinary project. Take the some I will say scientists from social science, some scientists from humanities, so that our I will say acceptance for the product will be very high. I want to share with you. I should not tell. More project, more Tezpur Vishwavidyalaya মই আছিলো. I was in Tezpur University 29 years. And there, I spent 29 years. I was associated with different projects. I submitted project to the DBT, DST. I got lot of projects. International projects I got. And this international project, one project with the Federal University of Rio de Janeiro, Brazil. And our Professor Colita was also associated with that as a QPI. So Brazil, when I went to Brazil, I was there around 2 months. When I went to Brazil, I was asked to deliver some lectures. I started the lecture from very small thing. So I mentioned, what type of small thing? I mentioned it, that I converted the waste cooking oil. We have a lot of restaurant. That waste cooking oil converted to the biodiesel. How? I use the peel of banana. How ভীমকল যেটো কয় তার বাকলিটো এরিয়ায় তাক মোৰ ষ্টুডেন্টে কৰিছিল আমি গ্ৰুপত কৰিছিলো বাকলিটো পুৰি মেলে তাৰ যেটো ক্যাটালিস্ট পাইছিল that catalyst was used to convert the waste cooking oil to the biodiesel. This is a big achievement. Then I went to Finland. There Finland also I have a project. In Finland, what I got, I delivered about the microalgae. Para তোমাকে খেলাই দেখিছা সবৰে খেলাই বিলাক আছে এনেকুৱা কিছুমান খেলাই আছে পানীত থাকে গ্ৰীণ আলগি চকুৰে দেখা নাপায় সেইবিলাক যেতিয়া তোমালোকে মাছ কাল্টিভেশ্যন কৰিবা গ্ৰীণ আলগি বিলাক কৰিবা তাতে এই বাটাৰ পৰা অইল ওলাই সেই অইলটো ডিজেলত কনভাৰ্ট কৰিব পাৰি সেই গ্ৰীণ আলগি চৰ্চ বিলাকক বিকল্প কৰিছিল তাতে এভৰিবডি হেজ একসেপ্টেড ওকে মই সেইকাৰণে কৈছো আজি আৰু বেছি সময় নকওঁ ইফালে হয় আৰু বহুত আমাৰ কিনোতে এড্ৰেছ কৰিব আছে আৰু আমাৰ ডিপিটি সায়েন্টিস্ট সকলো আছে so dear participant as you stand at the threshold of what many call the biological century this is the biological century becoming one of the big force now it becomes essential for your young researcher and student to harness the power of applied biology with responsibility ethics and innovation and interdisciplinary collaboration between biology, chemistry, physics, engineering, data science, and social science. I urge the participants of this seminar to use the platform not only to present their research findings, but also to explore new partnerships, exchange ideas, and inspire future directions. So, the fruits of applied biology must reach the farmer in the field, must reach the patient in the hospital, must be the community starving for us. Before I conclude, I would like to thank the Department of Biotechnology and Government of India and also the congratulate the organizing committee for organizing a very nice seminar and also for give us a very nice treat. Morning breakfast and tea, everything was very good and nice audience also very nice and I am so happy to come in this important institution that this institution have a glorious past and this institution have a very nice introduction everything. I wish this seminar will be a successful one. With this I would like to conclude. Thank you.
Indeed a fruitful speech. Thank you, Honorable Professor Deka sir. Your engaging speech and practical advice were instrumental in making this event a success. We are happy to share with you that the Department of Political Science, Tihu College, is going to inaugurate a peer-reviewed journal entitled Journal of Social Sciences and Humanities. I request the editor of this journal, Dr. Ratul Chandra Kalita sir and Mr. Rajiv Boro sir to come on the dais for the inauguration of the journal. At the same time, I request Honorable Vice Chancellor of Bhattacharya University, Bojali, Professor Dhanabati Deka sir to inaugurate this journal. I request the editor of the journal, Dr. Kalita sir, to give a few words about these journals.
Good morning to all of you assembled here today on the special occasion. Respected Principal of the College, Dr. Suresh Murali, Honorable President of Governing Body of our Institute, Tihu College, Dr. Narayan Kumar sir. Of course, the volleyball possibility could not be present on this occasion today. It is urgent international cooperation meeting which is going to be held at Raab today. Just few minutes ago, he informed about phone. Honorable Mohan Professor, Vice Chancellor of Krishna Guru, I think Krishna Vedana, Nohatra, Honorable Kalapati Legacy, Vice Chancellor of Bhattacharya University, Honorable Dr. Sahajuddin Ahmed, the Scientist and Director, Global Innovation Director, International Cooperation, the DBT Government of India, invited scientists, faculty, principals from different institutes, and participants from different institutes to participate in this students' national experience. My dear college students, I am very much thankful to Principal Bhavani sir for and also the seminar organizing committee for giving me this opportunity to inaugurate this journal on its citizens. And actually, all of you know that our first cycle of NAC assessment, the key thrust was on promoting research culture in 2003. So since then we are trying to do something, but I think this is the first peer-reviewed journal from this office. This is my first attempt from a Department of Political Science, where I am working tirelessly. This is the first peer-reviewed journal from this institute, and I am going to publish at least 5 series of journals each year. So thank you for giving me this opportunity, and I hope for the best in the future. Thank you.
Thank you, Dr. Kalita sir. Now it is time to hear from our honorable distinguished guest, Professor Sahajuddin Ahmed sir. I request Professor Sahajuddin Ahmed sir to deliver his speech on the topic entitled Empowering and Enabling Biotech Innovation Ecosystem for a Self-Reliant India. Sir.
Good President, Governing Body, Honorable Vice Chancellor of Auditorium University, Dr. Dekha, Honorable Vice Chancellor, Krishna Guru Adhyatmik Vishwavidyalaya, Dr. Kalita, Principal Tihu College, Dr. Borali, Vice Principal, Dr. Bhuya, and my Guruji and Director of Research, Dr. Robert Gora. All the invited speakers, faculty of Tihu College, and also invited speaker, and my dear student friends. Really today it is a great day for me, especially to attend this special event in Tihu College.
This process was initiated, I think, 6 months before. Although I have close relation with Tihu College from last 5 years, since my wife was the faculty in botany, and last 5 years, from 15 to 20, he was the faculty in Department of Botany. And during that time, many times I have visited, and especially I am thankful to Dr. Bhorali for inviting me and providing this opportunity to speak in front of all these dignitaries as well as all these speakers and my dear friends. So I request Dr. Joshi and Dr. Bhardas to excuse me because I want to speak a little bit Assamese so that directly I can contact with my Gen Z all students. Okay? Yeah, please. মই অকণমান মোৰ বিষয়ে ক'ব ওলাইছোঁ মোৰ ঘৰ ইয়াৰ পৰা 20 কিলোমিটাৰ আঁতৰ কমনা হাইস্কুলৰ পৰা কোনোবা আছে নেকি কমনা বিনাপানী হাইস্কুলৰ পৰা ষ্টুডেণ্ট নাই চাগে মই কমনাৰ হাইস্কুলতে পঢ়িছিলোঁ মই তাৰপিছত 1996 চনত পাটাচাৰকুছি বিদ্যাপীঠ নাইচ টু সি মাই ফ্ৰেণ্ডছ সুভাষ বৰ্মন ইজ হিয়াৰ চ' হি ইজ মাই ক্লাছমেট ডিউৰিং আৱাৰ ক্লাছ 12 তাৰপিছত মই ভেটেনাৰী সায়েন্স আজিৰ যুগত যেনেকৈ সুবিধা আছে সেই সময়ত দুটা অপশ্যন আছিল আইদাৰ MBBS আৰু তুমি যদি MBBS নোপোৱা তোমাৰ কামে নাই বা ইঞ্জিনিয়াৰিং তেনেকুৱা তেতিয়া ক'ত যাব কি কৰিব কোনো এডভাইচ দিয়া মানুহ আমাৰ নাছিল কাৰণ আমি হলো একদম গাঁৱৰ ল'ৰা আমাক কোৱা মানুহ নাছিল যে কি পঢ়িব লাগে সেইমতে আমি যেতিয়া ওলাই আহিলোঁ অকণমান টিহু পাঠশালালৈকে দেখিলোঁ কি মোৰ ক্লাছমেট কেইজন মানে কৈছে কি নহয় আমি ভেটেনাৰী সায়েন্স পঢ়িম অন্তত আমাৰ গ্ৰেজুৱেটেড অফিচাৰৰ সাইন কৰি আছোঁ এটা মানে ৰেছপনচিবিলিটি পাম কি এটা থাকিব আমি ভেটেনাৰী ডক্টৰ হওঁ ঠিক তেনেকৈ 97ত এপ্ৰিল মাহত মই ভেটেনাৰী সায়েন্স এডমিশ্যন লওঁ আৰু তাৰপিছত 2002 চনত মোৰ গ্ৰেজুৱেশ্যন 2005 মাষ্টাৰ ডিগ্ৰী আৰু 2008-9ত মই PhD from Indian Veterinary Research Institute যিখন বেৰেলি IVRI South East Asiaৰ এখন অন্যতম ইনষ্টিটিউট য'ত 1897 Robert Koch he did his pioneering research on TB and 1905 he got the Nobel Prize. So সেই ইনষ্টিটিউটে PhD কৰিবলৈ পাই খুব মানে নিজকে ভাগ্যৱান যেন লাগিছিল যদি ৰিয়েলি ট্ৰু হয় কি যদি IVRI ভেটেনাৰিয়ানে পঢ়ে বা চিট পায় চিট ল'বলৈ টান যদি চিট পোৱা যায় তেতিয়া ফেকাল্টিটো পাবই ক'ৰবাত সাইণ্টিষ্ট পোষ্ট পোৱাটো ইজি হৈ যায় ঠিক তেনেকৈ গৈ মই 2009ত PhD কমপ্লিট কৰি মই 3টা চাকৰি একেলগে পাইছিলোঁ সেই সময়ত ত্ৰিপুৰা ভেটেনাৰী কলেজত মোৰ এপইণ্টমেণ্ট লেটাৰ আহিছিল ছাইড বাই ছাইড DBTত মই নেশ্যনেলি কম্পিট কৰি মই তাতো চিলেকশ্যন হৈছিলোঁ কিন্তু ভাবিলোঁ কি যে মই যদি কলেজ জইন কৰোঁ এখন সীমিত পৰিয়ালত থাকি মই মানে মোৰ শিক্ষা দান কৰিব পাৰিম কিন্তু যদি মই DBTত জইন কৰোঁ তেতিয়াহ'লে মই গোটেই সমাজখন অল সায়েন্স নট অনলি ভেটেনাৰী সায়েন্স অল জেনেৰেল সায়েন্স নেশ্যনেল ইণ্টাৰনেশ্যনেল ৱাইজ মই সহায় কৰিব পাৰিম ঠিক সেই মতে মই ইণ্টেনশ্যন লৈ জইন কৰিলোঁ আৰু লাষ্ট 16 ইয়াৰ্ছ ছাৰ্ভিচ দি আছোঁ এতিয়া কাৰেণ্টলি মই ইণ্টাৰনেশ্যনেল উইং যিটো ইণ্টাৰনেশ্যনেল ডিভিজন অফ ডিপাৰ্টমেণ্ট অফ বায়'টেকনলজি মই হেণ্ডেল কৰি আছোঁ আৰু তাত কেনেকৈ মই দেশবিলাকৰ লগত কেনেকৈ বাইলেটাৰেল ৰিলেশ্যন আমি হেল্প কৰিব লাগে সায়েন্স ডিপ্ল'মেচিৰ ৰোল প্লে কৰি আছোঁ গতিকে খুবেই এটা ইম্পৰ্টেণ্ট পৰ্টফলিঅ' এইটো এনেকুৱা পৰ্টফলিঅ' হেণ্ডেল কৰিব পাই খুব নিজে আনন্দিত আৰু লগতে from whenever people ask me you are from Assam it gives me pleasure no yes I am from Assam and I am the only scientist in Ministry of Science and Technology from whole Northeast not only from Assam whole entire Northeast there was not a single person from Northeast and still today no one is there except me so মাজে মাজে ভাব হয় যদি মই অন্তত মিনিমাম ইনফৰমেশ্যনখিনি দিব পাৰোঁ আপোনালোকক that will be a great job from my side কাৰণ ইনফৰমেশ্যন বহুতেই নাজানে আমি কি কৰি আছোঁ কি কৰোঁ আমি কেনেকুৱা বস্তু প্ৰিফাৰ কৰোঁ সেইবিলাক বস্তু ইণ্টাৰনেলি অকণমান জানিলে হাউ টু ৰাইট এ প্ৰপ'জেল হাউ টু ডিজাইন এ প্ৰপ'জেল এইবিলাক যদি অকণমান হিণ্টছ যদি ইণ্টাৰনেলি মই দিব পাৰোঁ তেতিয়াহ'লে নিশ্চয় মানে সহায় কৰিব গ্ৰেণ্ট পোৱা যোৱা ছমাহ আগত মাৰ্চ মাহত আমি ডিচাইড কৰিলোঁ কি আপোনালোকে এখন সৰু চেমিনাৰ এইটো আৰু মোৰ যিখিনি মোৰ কাম থাকে মই কৰি দিম তেনেকৈ তেওঁলোকে খুব একাগ্ৰতাৰে, and the team, I am very grateful that whole team is actively, they are working, and this is the first time I have seen in Assam or whole country. Oh, nicely, although it is a small seminar, but it is not a small thing. The way they are developing it, way they are involved with this, really, and for this they really need a best. So under the leadership of Dr. Bhorali, they are really doing a great work. I reached from Delhi yesterday. From landing onwards, that they were calling me, sir, not only me, everyone. Dr. Bhordas was telling me that the way people have given his hospitality, he really is nice. His first visit. And we all are happy that by seeing all this arrangement and all. Really, we are grateful. And more follower pora moi jiman jenekoi ne ji koribo lage apnaloke adesh koribo, mok request nohoy je etu mok order di dibo je etu koribo lage, etu koribo nalage, mok koi dibo hemote mor কাম কৰিব 100% চেষ্টা কৰিম। গতিকে আপোনালোকে কামবিলাক কৰি যাওক, ভাল লাগে আমাৰ। কাৰণ গুৱাহাটী ইউনিভাৰ্চিটি বা টিহু কলেজৰ লগত মোৰ কোনো পাৰ্চনেল ৰিলেশ্যন নাই, কিন্তু যেতিয়া এটা প্ৰপ'জেল গুৱাহাটী ইউনিভাৰ্চিটিৰ পৰা পাওঁ, আসাম এগ্ৰিকালচাৰ ইউনিভাৰ্চিটিৰ পৰা পাওঁ, বা তেনেকৈ নেহুৰ পৰা পাওঁ, all parts of North East, then really I give my 3-4 times thinking more what to do, and accordingly I act on it. আৰু যিমান পাৰোঁ সহায় কৰি আছোঁ মানুহক, আৰু সহায় কৰাটো আমাৰ দায়িত্ব। কিন্তু অকণমান যদি আমাৰ হায়াৰ অথৰিটিৰ ফালৰ পৰা অকণমান প্ৰেছাৰটো কমি যোৱা যেন অনুভৱ হৈছে মোৰ। Those who are holding highest positions like universities, VCs, all VCs, I request all VCs to take responsibility, because we can do lot of things for Northeast. Every ministry has their 10% earmark budget. Nobody knows it. Only Department of Biotechnology is implementing. অকল আমি ইমপ্লিমেণ্ট কৰি আছোঁ যে 10% বাজেট আমি নৰ্থ ইষ্টৰ কাৰণে খৰচ কৰিম। ঠিক তেনেকৈ 2009 পৰা আমি 10 year স্পেচিফিক প্ৰগ্ৰেম ডেভেলপ কৰি আছোঁ, কিন্তু অকণমান স্পীডটো মোৰ পাৰ্চনেল অবজাৰভেশ্যন অকণমান কমি যোৱা যেন লাগিছে, আৰু হোপ ভেৰি চুন ইট উইল কাম আপ। ত' এনেকৈ আগবাঢ়িব, ভাল ভাল প্ৰপ'জেল পালে আমি নিশ্চয় সহায় কৰিম। বাট এনেকৈ এইবিলাক আমাৰ কাৰণে অকণমান এখন এটা সেমিনাৰ হৈছে বা এখন কনফাৰেন্স এৰেঞ্জ কৰিছে 2 দিন 3 দিন, এই বস্তুটো যদিও দেখাত লাগে যে কি অকণমান এটা ভেৰি স্মল থিং, বাট ইটছ নট এ স্মল থিং, ইটছ ৰিইউনাইট। টুডে আই এম হেপী টু সি ডক্টৰ যোশী, ডক্টৰ Bhordas, and all you have come from Inaugural University, so you have seen Tihu College. Like that, Robert Bora sir, he is actively working, truly working, and he is also associated with many committees of the Department of Biotechnology. So like all will be involved, then work for the development of the community, for Northeast community. Once we can develop our community, then automatically we will get more attraction. Today, some people are saying that, recruitment purpose. Why you are thinking for a simple job? You should give your time. Gen Z, please listen it. So it is the time. Not only you should have one smartphone in your hand. By intellectually you should be smart. You try. You perform well in the exam, ভাল ৰিজাল্ট কৰা, ভাল ইনষ্টিটিউট। মই এতিয়া ইণ্টাৰনেশ্যনেল ডিল কৰি আছোঁ। ডেইলি প্ৰত্যেকখন দেশ, মই টাইম দিব নোৱাৰোঁ, প্ৰত্যেকখন দেশ ইণ্ডিয়াৰ লগত কাম কৰাৰ কাৰণে আগ্ৰহী। ডেইলি সিহঁতে আহিব বিচাৰে, কলাবৰেশ্যন কৰিব বিচাৰে। কিয়? সিহঁতে জানে যে ৰিচোৰ্চ ইণ্টেলেকচুৱেলি ইণ্ডিয়া হেজ গন ফাৰ এৱে। চ' নাও ইটছ দ্য টাইম টু ৱৰ্ক উইথ ইণ্ডিয়া। ৰিচেণ্টলি স্পেচ মিছন, শুভাংশু শুক্লাৰ নাম শুনিছে, 7টা এক্সাম্পল, 7টা স্পেচত 7টা টেষ্ট কৰিছে, 7 টেষ্ট, and out of 7, 3 from the Department of Biotechnology. Then microgravity and meiosis related. স্পেচত গ'লে মাচুলবিলাক কমজোৰ হৈ যায়। এইবিলাক কিয় কমজোৰ হৈ যায়, কেনেকৈ মাচুলবিলাক লছ হয়, কেনেকৈ ৰিগেইন কৰিব পাৰি, সেইটো আমি কৰি আছোঁ। সেইটো টেষ্ট, মাইক্ৰগ্ৰেভিটিৰ কেনেকুৱা ইফেক্ট, নিউট্ৰিশ্যন ফুডবিলাকৰ কেনেকুৱা হয়, সেইবিলাকক আমাৰ ডিপাৰ্টমেণ্টে সহায় কৰি আছে। গতিকে ইণ্ডিয়া হেজ গন ফাৰ এৱে। চ' এতিয়া আমি কেৱল পঢ়িব লাগে, থিংকিং কৰিব লাগে, আইডিয়া ক্ৰিয়েট কৰিব লাগে। আইডিয়া কেনেকৈ নতুন আইডিয়াবিলাক মনত আহে, লগে লগে কণ্টেক্ট কৰা, এইবিলাক ইমপ্লিমেণ্টেশ্যন কৰা। এনেকুৱা নহয় যে কি মই BSc পাছ নকৰালৈকে মই একো কৰিব নোৱাৰোঁ। ডিগ্ৰী ইজ লাইক ডেট যিকোনো কাম কৰিব পাৰে, হাজাৰ। ডেকা ছাৰে কৈছে যে কি 10,000 startups. Yes, more than 10,000 startups already we have supported. তোমাৰ যদি এটা নতুন আইডিয়া আছে তুমি যদি এইটো ইমপ্লিমেণ্ট কৰিব পাৰা একেদিনাই তুমি চাকৰি এটা নুকি তাতকৈ হাজাৰ গুণ তুমি নিজেই এই কৰিব নোৱাৰিবা যে কিমান আগুৱাব পাৰি যেনেকৈ তেখেতে ক'লে জিন থেৰাপি বা এইবিলাকৰ কথা গতিকে IIT দিল্লী ডক্টৰ ৰাহুল বৰুৱাৰ তেখেত কাৰ্টিচেল এইবিলাক মই অকণমান আছে মোৰ প্ৰেজেণ্টেশ্যন কেনেকৈ আমি যিটো কাৰ্টিচেল US-ত ট্ৰিটমেণ্ট কৰিব লাগিলে ব্লাড কেঞ্চাৰৰ এগেইনষ্ট 3 বা 4 কৰোঁ কিন্তু এতিয়া আমি টেকন'লজি আমাৰ ইণ্ডিয়াৰ 30 to 40 লাখত ব্লাড কেঞ্চাৰ ট্ৰিটমেণ্ট সম্ভৱ হৈ গৈছে আহিছে মাৰ্কেটত এইবিলাক এভেইলেবল আহি যাব আৰু যে বায়'টেকন'লজি নেক্সট 30 to 40 ইয়াৰ্ছ যেনেকৈ 90ৰ পৰা IT ৰিভলিউশ্যন হৈছিল আমাৰ ইনফৰমেশ্যন টেকন'লজি চ' নেক্সট 30 ইয়াৰ্ছ বায়'টেকন'লজি and today I tell you next 40 years that biotechnology biology that will dominate all the areas and you are lucky that during your time only all this will happen and please train your mind to think like that only how you can contribute to the society besides doing your normal job but scientifically how you can give your thinking to product to the society মই অকণমান প্ৰেজেণ্টেশ্যন মই ভাবিলোঁ কি অলপমান ডিপাৰ্টমেণ্ট অফ বায়'টেকন'লজিত যদিও সম্ভৱ নহয় 38 ইয়াৰ্ছৰ গিফ্ট উইদিন 10 বা 15 মিনিটছত মই ট্ৰাই এটা কৰিম কি কৰি আছোঁ আমি কি কৰা নাই সেইমতে অকণমান ইনফৰমেশ্যনখিনি গেডাৰ কৰিবলৈ ট্ৰাই কৰিলে হ'ল আৰু বিশেষ কিবা লিখিব লাগিলে ইউ কেন ডিৰেক্টলি ৰাইট টু মি বিকজ আই কেম ফৰ ষ্টুডেণ্টছ অনলি ফেকাল্টিজ দে নো উই হেভ ফিনিছ আৱাৰ টাইম হাৰ্ডলি 15 years time we will be in the government system then you will be in the society to lead all these activities please ঠিক আছে মই তললৈকে গৈ কৰি হ'ব
If our respected dignitaries wish to enjoy Sahajuddin Ahmed sir's lecture, they may sit in the front seat.
So, you know, I'm from Department of Biotechnology. Sir, Pishot.
Sorry, next poem my next reading. Sir, next poem my next slide, Mark.
Next. Yes. So, মই ভাবিলোঁ কি I just thought that I'll keep it on empowering and enabling biotech. Yes, please. So my topic is empowering and enabling biotech innovation ecosystem for a self-reliant India, Atmanirbhar Bharat. All we are working towards that already Honorable Prime Minister has declared that by 2047, 48 চনত 2048 চনত আমি ডেভেলপ কান্ট্ৰি হিচাপে আমি কৰিবলৈ আমি অলৰেডি এইম লৈছোঁ ন so to reach that Atmanirbhar Bharat, Department of Biotechnology actively working to achieve that Atmanirbhar Bharat. But my personal views, if somebody asks me what is your vision, but my vision, Bharat, Nirbhar world, so that one day will come, everybody will be dependent on India. Next. Next slide. Yeah. So under the Ministry of Science and Technology, Government of India, these are the three departments. Department of Science and Technology, that is short, it is called DST. Department of Scientific and Industrial Research, DSIR, and Department of Biotechnology. So DST, they are having I think 23 autonomous institutes. Like that, CSIR, they are having 37 national labs. Yeah. Okay. Okay. So, DST, they are having 23 autonomous institutions, and currently one of the institute is in Guwahati. Then second, DSIR under CSIR lab, 37 national laboratories are there. In Northeast also, then in Jorhat, one institute is there. Like Department of Biotechnology, we don't have any institute in Assam, but in Imphal, Manipur, we have one institute. Yeah. So I will speak about the Department of Biotechnology. Our remarkable journey started in 1986. So our department was established in 1986, and from that last almost 39 years, we are serving the nation, and currently we have our 15 autonomous institutes, 13 autonomous institutes like other structures, BRIC, Biotechnology Research Innovation Council. So the government of India are trying to reduce the institutes, but what we did, that under one umbrella, BRIC, like CSIR. So what we did, 13 institutes we included on that, and 2 more institutes that ICGB, you all know, International Center for Genetic Engineering and Biotechnology, and RCB, Regional Center for Biotechnology, it is in Faridabad. These 2 institutes are separate because they are established as per our Parliament Act. And we have also like public sector undertaking, like Bharat Immunological Biological Corporation, Indian Vaccine Corporation, then Biotechnology Industry Research Assistance Council. So these are 3 private undertaking companies where they, once we develop all these technology, all technologies are being funded by BIDEC for development of further for the product. Next. So like every department have their own visions. Like our DBT has their own visions, like attaining new heights in biotechnology research, shaping biotechnology into a premier precision tool of the future for creation of wealth and ensuring social justice, especially for the welfare of the poor. So every department, every ministry has their own vision. Ultimate aim is to develop the society. Next. So we have also our own missions, like realizing the full potential of biotechnology, a well-defined directed effort, significant investment for generation of product, process and technology. This is the main. Our aim is to develop product, process and technology coordination. Next. So these are the mandate, like being in the ministry, so promotion of biotechnology is our sole activity. R&D and biomanufacturing, autonomous institutions of DBT, set up center of excellence, promote university and industry interaction, integrated program for human resource development, serve as nodal point for international collaboration, establishment of infrastructure facility support, and R&D and production. Next, we are also developing that guidelines, all biosafety issues, all regulations matter. Then all these are being supported by DBT. Next. So I told you, we have that 15 autonomous institute, like especially in NII, all immunological activities they are doing. Like NIAB, we have our single institute, National Institute of Animal, National Agri Biomanufacturing Institute. The recently name has been changed. Like CDFD, Center for DNA Fingerprinting, like INSTEM for Stem Cell Research, NIOB, National Institute of Animal Biotechnology, then ICGB, I already told, RCGB, then NCCS Pune for Cell Science, ILS Bhubaneswar, NBRC, that National Brain Research Center in Manasar, and NIBMG Calcutta, then PHSDI, this is in Faridabad. So all these 15 institutes and 3 private institutes. We are a very small family, but our contributions are good. Next. So that BIDEC, everybody knows it, I think those who are involved with product process development. So once we develop any product process from our R&D, then that goes to the BIDEC. So BIDEC supports to the next step for the product development. Okay. So currently department has our nine directorates. Earlier we called it division, like internal division or internal directorate. Like technology, capacity building and partnership, societal development programs, one directorate who leads all these activities. Health and health wellness, all medical related activities this directorate is responsible. Like information system biology, bioinformatics, AI, all related this program are being dealt by this division. Then I am dealing global innovations, that international partnership programs for all bilateral, multilateral relations. Then data monitoring and analysis, so I'll come later on. What is the importance of data in biological science? Then advanced biofuels and sustainability, that is also one directorate. And under that directorate, that one part is NER, Northeastern region. Then biowealth and biosafety, all agriculture, animal, fishery science comes under it. Then this is the important area for the emerging scientists, those who are just recently completed PhD or joint faculty, who can submit their proposal under this emerging frontiers biotech. So this is recently added by thinking that those who are recently joined faculty or like that, not those who have completed their PhD, they can apply and their budget is limited up to 100 lakhs, 1 crore. Within 1 crore, they can initially establish their lab. The next one. So this is the current funding mechanism. We all democratic way we evaluate the proposal. It is not that somebody has submitted the proposal, we individually we do. No, we follow a strict democratic process. Once we receive the proposal, then anything, either it may be generated proposal or call for proposal. So that goes to the internal screening committee. Internally we don't see much about the science, but the administrative procedures, whether institute is eligible, whether TI is eligible, or something like administrative which helps to push it to the next level. Once it gets clear from the internal screening committee, then proposal goes to the reviewers, experts. So every proposal what we do, we have our own list of reviewers. Although PI used to write 5 experts whenever they submit the proposal. But in general, no. By thinking that there may be conflict of interest, suppose I know you, suppose I know that I will keep my brother's name, and definitely he will help me in getting the proposal. But sometimes we keep 1 or 2% from there and for 80% from outside, so that we can really give the justice to the PI. Yes, this proposal is good and we can support it. So once they clear all these reviewer comments, then we call for presentation to the technical expert committee. So that committee is the final. After that, if your proposal is recommended by this committee, then ultimately all financial and administrative proposal, it goes for implementation. Some not only proposal we give fellowships, like one of the best fellowship for the women population, for specifically those who have dropped their after PhD or like that, due to all this, their marriage and shifting of their working place. So for them, we have developed that biocare fellowship. So biocare fellowship also we divide the 2 categories: one for PhD, then one for MTech biology, other allied studies. Their fellowship is also for PhD. We give 60 lakhs for 3 years or like that. And in their projects, if they are not working, they get around 70,000 as a fellowship amount for their monthly, so that they can run their day-to-day activities also. And for research purpose, we give about 60 lakhs, which they can easily perform their activity in a lab. And like that, this amount is also 40 lakhs, which we give fellowship amount 50, so that they can at least start their activities, those who have left from the PhD level. And next, for in general DBT, we support junior research fellowship, DBT research associateship, skill development program, Argovindo Corona, these are international, biotechnology industry training program, then Tata Innovation Fellowship. Then opportunity life, we also not only support projects program, we support the master degree program like MSc biotechnology, like veterinary science, agricultural science, medical science, all we support. And currently more than 70 courses we are supporting from the India. Then more awards like National Biotechnology Innovation Award, Janki Anmol National Women Bioscience Award. Next. This is the important, that international fellowship, Ramalinga Sami, then MK Bhan Fellowship, In Ramalinga Sami, whenever somebody is in foreign country and they want to back to their motherland, to serve in motherland, so after 45 years of age, they can come. They can avail this fellowship, and their fellowship is around 1,40,000 fellowship monthly we support, and we give him special programs so that he can establish his lab, any institute or college, even university. So this is a good fellowship, and this is we are implementing from 2008-9 onward. So almost last 17 years we are supporting. Then MK Bhan was our former secretary. So in his name we have developed this fellowship. And one disadvantage is that only in our institute, he or she can do PhD in DBT supported institute only. And good amount of fellowships we provide, 75,000 for his PhD. Next. Then distinguished biotech research professorship fellowship, all those who are retired or like that, they want to continue. For that also, we have developed some projects. Next. Then Corona fellowship, Tawas fellowship, all are there. You please visit our website because for me it is not possible to speak all the program within 10 or 15 minutes. Next. So this is the fellowship, no? IIT Bombay and Manas University of Australia. For 1 year, those who are in the PhD and all, so they can, their final year period, they can visit that Manas University and they can complete their PhD in that. So like dual purpose degree, no? As per national education policy, all these are coming now. We have already started, I think, more than 10 years back. So everybody knows DBT about this, no? Star College scheme. So this is a good scheme and it was started in 2008. And the purpose was great, but only the implementation institute, they know how they are implementing. The record comes to us, but what we do. No? People know DBT's intention is good. We give good amount of money, but it is the duty of the implementing institute and implement those who is involved in the implementation. So they should spend the all what the objectives. No? You got it? So by thinking all this, we knew that during that 2008, then Dr. M.K. Bhan was the Secretary of Department of Biotechnology. And he was the true visionary for the Department of Biotechnology. And during his time, all these new programs, like 9 institutes, all these new, because one day he visited some college in Delhi University or like that, then he realized that some institute, even they don't have microscope and all. So immediately he told the DBT officer, develop some program so that we can help throughout the country in the college, where we can give one microscope, or like that minimum facilities within 30, 40 lakhs, that time, before 17 years. So with that intention only we developed this program. And I know that currently more than 300 colleges we are supporting. And yeah, more than 317 colleges we are supporting. And 45 colleges have already achieved the star college. So there are various stages. Initially we give to develop the infrastructure. Once it developed, then we second grant. Then finally we give the status of star college. Otherwise, everybody is not under star, but it is under star college scheme. So key objective all this, to strengthen, to promote networking, strengthen ties, neighboring institutes and other. Our objectives, our things are great, but everything depends on the implementation institute. So how they develop. Because we don't have time to see each and every project. We are only 40 scientists in the department. We all are overloaded. And persons like me, I am handling all international, plus supportive. I'll show you that some of the programs very important. And currently that one program, our scientific colleagues, they know about DBT Welcome Trust India Alliance program, one of the prestigious fellowships. That is also I'm handling. And currently we are going to get the cabinet approval. And for that interministerial consultation I am doing. And I think 18 is the last date for giving comments by all the ministries. And once they give the comments, then there will be 1,500 crore major programs for DBT and welcome. So these are the distributions of all. Currently we are having I thought that I should show that Assam. 24 colleges are covered, but only one college is given this star. And Tihu college is also having star college scheme. Next, this is the important program, CTEP, TTEP. C for conference, E for travel, E for exhibition, and P for popular lecture. In what we did in this, so like college or university, once they want to any seminar like this, no, or conference, or somebody wants to visit any country to present their proposal, then their findings. So travel also we give. For conference we support. Like exhibition, if you want to conduct 1 or 2 days exhibition program, whatever has been developed, suppose in Northeast, we want to show 1 day, so arrange one program in somewhere. So for that also we give funding. And lecture, anybody. No, because sometimes in program like in national seminar and all this, we get limited time. No? We don't get much time to express our all things. No? Like that time is very limited. But we can separately, we can invite someone. Even Nobel laureate, if you want to invite someone, we will support. That institute, university, college, or other, they can invite, and we will support all this, whatever expenditure is in. So these are this is the program under CETA. Next. So you know at Biotech Park, that DBT has established almost 9 biotech parks in Guwahati, IIT, under IIT also we have 1 biotech. The main aim is to support all these startups and all, so that they can come and do their initial work, where they can think for the product development, process development, or technology development. So this is also one of the best team of DBT. Next. So I told you that about directorates, 9 directorates. So under medical biotech, we divide like this. All chronic neurological disease, infectious disease. We have special program on cancer. So recently we have initiated like with US, that cancer monitoring program, everybody knows. So we have also collaboration with that. Then development of diagnostic, vaccine, drug development, cell and gene therapy we have started. Then women and child health nutrition, all programs we support under medical biotech. Next. Then biowealth and biosafety like agriculture, animal biotechnology, all livestock, aquaculture, plant biotechnology, bioresource, all regulatory methods, this division, they handle all. Next. This is the information system biotechnology directorate, which supports all computational bioinformatics and AI. So IBDC, I will tell you later. Then UNMID, these are the programs. Then Genome India, recently India has sequenced 10,000 human genome. This was the news. So that program also comes under this division. Then microbiome, then BTIS net center, Bharat Inaugural, he was involved actively. So last 30 years we were supporting all these programs under BTIS net. So under BTIS net we have supported more than 150 bioinformatics centers for the country, and big numbers in Northeast also. So after that, due to all these paradigm shift in information technology and biological research, we have shifted our objective to someone, so that we can develop data, and that data can be utilized centrally. So for that purpose, we have revamped whole bioinformatics division. Right? So this is the distribution of BTS for the country. Next. This is the emerging frontier biotechnology. Please visit DBT website and you will find out. Under that, we have divided 2 divisions. One, biomedical sciences, they will deal all these health related, and biological sciences other than health. So under this program, we will support, and this will be open for submission January to March and July to September. So 30 September is the last date. Every year, we give 3 months period for submission and 6-month period for all this processing and implementation. And under this advanced biofuel sustainability and NER, actually earlier NER itself was the mini DBT. So lot of programs. When I joined in 2010, at that time the program was just started and all twinning program. Everybody knows that DBT twinning program is in a large way. But time being, I think this is little bit going down, and hopefully we'll get a good number of proposals. So NER from 2010 onwards, we are actively supporting, especially 10% budget. NER 10% budget, we are spending under biotechnology. So other departments also, they are also bound to spend, but I don't know in what way they are about. So this is my directorate, Global Innovations Directorate, and we support all global strategic partnership programs, all international programs Bilateral, this is country to country between two countries program. And this is multilateral, when more than two countries are involved. Then we signed multilateral this under MOU. Then NGOs are also there, like Bill Gates Foundation, Welcome Trust. These are the big foundation. So they support. Like Welcome Trust, now they will give us 500 crores under that DBT Welcome Trust. So we will give 1,000 crores, then they will give 500 crores. So ultimately 1,500 crore proposal will be designed. Then other organizations are also there. Yeah, yes. So bilateral, we have more than 84 MOUs with 84 countries. So currently, we are supporting almost 30 countries actively. And we have almost 100 projects, ongoing projects with, including US, UK, all Europe part, and even Asia. So under multilateral, we have like BRICS, then HFSPO, all these, MBO, then BMSDF, all we are supporting under this multilateral. Next. So these are the distributions of our projects for the world. Next. Yeah. So NSF, you all know, no? National Science Foundation in US, like DBT in our India. So we support biotechnology. But in US, they are supporting 50 countries in US. That is the organization NSF, National Science Foundation. So last, I think 23, we signed the MOU with NSF, and we are all, currently we are just supporting projects under NSF. So good number of projects are being funded, and they are working basically in synthetic biology, cancer, then special program on eyes, ophthalmology. Next. So that is the program currently under consideration by Union Cabinet. So earlier this program was started phase 1 in 2008. This was for 10 years. So that time our contribution from DBT and Welcome Trust. Welcome Trust is the NGO in UK. So 1:1. Suppose if they give 500, then first time we also supported 500. So ultimately 1,000 crore. In 2018-19, that phase 2, we told that we will give double amount. Suppose we will give like 1,000 crore and they will give 500. So second phase also successfully completed. Now we are working for the third phase. Already Department of Expenditure, Ministry of Finance has approved this proposal with 1,500 crore budget. And hopefully in the next month, we are expecting to get cabinet approval. And this will be a great achievement for the department that high grade, high quality research we will be able to do with UK. Next. So this is the regulation. We are also involved in policy regulations like all these guidelines we have prepared and we have already approved. All guidelines are approved by our government or cabinet. So accordingly, like this was also developed by our department, like Biotech Pride Guide, right? Promotion of research and innovation, data access. So I told you, what is the importance of data. So in 2012, next. In 2012, US declared that we will not give any data to India or even to whole Southeast Asia. So during that time, 2012, so from that onward, department was planning to develop some guidelines or center where we can centrally deposit our all data so that we can develop our own data for our own research. So thinking all this, we developed these guidelines. So this was the guideline. I was actively involved in the department and that Biotech Pride guidelines in 2021. We prepared it and it was approved by the government. So as per these guidelines, just like once you get any project from government funded department, anything, not only DBT, DST, CSIR or other, so you are bound to submit that data to our centers. We have developed one center, that is Indian Biological, next one, Indian Biological Data Center. So this is in the Faridabad. So once you develop that data, so we have next one. We have to submit your all data to this data center. So this is our indigenous Indian Biological Data Center. Please next. So once you develop all data, every PI, everybody should deposit that data in that center, and you will get not only Indian recognition. Internationally, we have already signed MOU that your project, your paper is well recognized for the world. So next. So this is the thing in August 24, Union Cabinet has approved, this is the policy. Bio E3 policy. Bio E3, that means economy, environment and employment. So biotechnology for economy, environment and employment. This policy approved in 2024 that Honorable PM himself, he took several rounds of presentation. Then he realized the importance of biotechnology and what we can achieve in the coming year. By realizing the importance, he approved this policy. Next one. So as I told you, no, 24 August 2010 policy. This is aiming fostering high performance biomanufacturing, which involves the production of bio-based products. So our aim is to develop bio-based products for green, clean and self-reliant house. So once we can develop all these, and this policy will really help to achieve that net zero carbon economy and promoting sustainable growth through a circular bioeconomy. So we have great expectation on this policy, and we are currently, although it is even just completed 1 year, and but by action we have done a lot of work. Next one. So it is good thing that Assam government and Gujarat government, these are the two states, they have already signed MOU with DBT. And from Assam, I was happy to share that our Chief Secretary was actively involved and he visited DBT and they signed the MOU for working under this policy. So under this policy we have identified 6 broad thematic areas like bio-based chemicals, enzymes. So that under this area we will develop all high value chemicals, enzymes. The second one, functional foods and smart proteins. No? So as you know, now the world population is almost 8 billion. By 2050, all population will be 9.7, almost 10 billion. So where from we will get the protein? To feed this high amount of almost 10 billion people, where from we will get the chicken, mutton or like this, no? So we have to create alternative proteins. So for that alternative proteins and all other foods, maintain food security and all, we have given much importance to this area. So we are actively working on this also. Then precision biotherapeutics. So under this, like immunotherapy, no, all CAR-T cell therapy, gene editing, all will work under this area. Then climate resilient agriculture, and agriculture is one of the most important. So we'll all climate crops and all these will work here, even all gene editing plants. Then carbon capture and utilization. Then last one, futuristic marine and space research. Although we thought that initially that we will not be able to do any work under space bioresearch, but it is now opposite, no? We signed a MOU and recently that I told you, we want to, yes, there's Sudhanshu Shukla, he did 7 experiments in space, and out of 7 experiments, 3 were from the Department of Bio. So almost we have started, and these are the private, public-private partnership, all artificial intelligence enabler, then bio manufacturing hubs. These are the enabler through which even international collaboration, through which we will try to achieve our goals. Next one. So generally some people, they call me and they ask me where we can apply in college and all this. Although they tell that we are not doing some biotechnology, but where we can apply. So now Anusandhan, ANRF, Anusandhan National Research Foundation has come. So this is being dealt by DSP. And their main purpose is to foster a culture of research. You please find it, that culture of research and innovation through India's universities, and I have both colleges, and research institution R&D laboratory. Because institute, national R&D, they will get fund from institute like DSP, DBT. But where from this, they will collect the fund. So now basic research, importance of basic research, we can't deny, and it's very important. So all colleges, they can directly submit proposal to ANRF, and ANRF, they are the apex body in directing all this. And as per the national education policy, the new education policy, so this is the apex body through which you can apply, you can take the grant in colleges also. And their purpose is to help the colleges, not only research, try to develop the culture of research, how we can continue, how we can create scientists. If you see the national average statistical data, then India, I think, per 10 lakhs of population, only 260 to 270. But per lakh, 2.7. 3% are not ready to do research. So, which is far away from our US and China. So that's why it is our duty to create culture of research in college. So college is the main thing, universities is the main thing. So please, all faculty, this is my special request to all the faculty, you get involved and try to involve your students and inculcate that research is important in India, through which you can do a lot of things. Next one. So this is the just somebody, Jaka sir I told now that vaccines and all this. We are the leader, global leader in vaccine manufacturing in India. And during COVID time, within 6 months period, we developed that Covaxin and all, and we helped in manufacturing Covaxin to Bharat Biotech. So like all these world's us and India's indigenous developed DNA vaccines, all sub-unit protein sub-unit vaccine, mRNA vaccine, lot of work we are doing. Then quadrivalent human papilloma, cervical cancer vaccines we have already developed. Then your India's fight against antimicrobial, no? So we have already developed with the support of BIRAC and DBT, nevitromycin. So nevitromycin is the antibiotic, its trade name is it now. So we have already developed, and that will be the fighting against the antimicrobial, no? So India has developed indigenous magnetic resonance machine, no, imaging MRI. Then we have also developed some novel blood bank. These are nothing but simple techniques. In general, in blood bank, they can keep up to 42 days. But our scientists have developed this where you can keep the blood up to 51 days and even more, that without any degradation of the quality. Then gene therapy of hemophilia, I told you that again blood cancer, that IIT Bombay has already developed CAR T-cell. Then this is the CAR T-cell already in the market. In US, it costs I think almost 3 to 4 crores per treatment, but in India 30 to 40 lakh. And we are trying to reduce even 15, how we can develop to 10 lakh or 5 lakh, so that it is available to the common people. Even 5 lakh, 2 lakh, one day will come. And we are also giving much emphasis how to develop. Already technology is there, medicine is there, how we can reduce the cost to make it more economical. Then only people will come, then India will be hub for even biomedical. So this is our aim. So as a small department, we are doing a lot of things, but today, very small time, I thought that 25 minutes is relatively low, but I will visit the next time and I will give all information, whatever I can, for the benefit of all our scientific community. Next, I think one more. So all these current global positions, 12 in biotech, in Asia 5. Indian biotech sector has already reached $165 billion industry and going to reach 300 by 2030. Then in global innovation index, in 2015, we were in the 81, and in 2024, 39. So hopefully within 10, we'll come the top 10 position. Then third largest startup ecosystem, more than 10,000 startup ecosystem we have already developed. And as I told that vaccine, one of the largest vaccine manufacturer in the world. Next. So all DBT and our secretary, he used to tell we are not the Department of Biotechnology. What we are doing, we are delivering for a better tomorrow. So how you can give the community. So please, next. So thank you. And generally I don't give speech. I prefer to interact because whatever I know, it is already with me. But I want to expect from the students or from the faculty because that's my duty to know from you. So you please write or talk to me. My phone number is already with your principal. If somebody wants to talk with me, you please talk. And if you want to know any program, if you think that I can help, please, most welcome. Thank you.
Thank you, sir. It was indeed an honor to have you speak at our event. Thank you for your informative and insightful talk. Your insights on biotechnological innovation for a self-reliant India is really appreciable. I request our students to have a huge round of applause for Honorable Professor Sahaduddin Ahmed sir. Thank you, sir. May I now request the keynote speaker of this inaugural session, Honorable Professor Prabodh Pura sir, to deliver his lecture on recent advances in applied biology and future prospects.
It's okay. Namaskar. Respected President of the governing body of this esteemed institute, Tihu College, my friend Dr. Narayan Sharma, the principal of this college, a young dynamic principal, Dr. Suresh Morali, two honorable vice chancellors sitting before me, my good friend Dr. Mohan Chandra Kolita, the vice chancellor of Krishna Guru Adhyatmik Vishwavidyalaya, and Dr. Dhanapati Deka, the honorable vice chancellor of Bhattadev University. The vice principal of this college, Sridhar Ramakanto Bhuyan, my good friends from Nehu, of course, one is from Dr. Devayan Bharadwaj is from originally SNU, but now he is in Nehu. I think he is coming from Nehu now, is it? So you are still in SNU. Okay, oh, fine. Along with Dr. Sosi, you have come. That's why I thought that you might be Nehu. My good friend Dr. Sar Joshi from Northeastern Hill University, Shillong. My younger brother and a part of the first generation bioinformaticians of Northeast, Dr. Pankaj Setia. I think many of you might not be knowing him. He is professor and head of the Department of Life Sciences, Tihu University now. He is almost like my student, although I could not find him in my classroom. Respected teaching fraternity of this esteemed institute, honorable principal, and the faculty members of the neighboring institutes, and my dear students. So we are running late by more than 1 hour, 15 minutes. So that again and again reminding me to cut short my lecture. I prepared a lecture for 35 minutes as it was allotted to me, but it was supposed to be started at 10 past 1. মই এটা দহত মোৰ বক্তব্য আৰম্ভ কৰিব লাগিছিল, কিন্তু এতিয়া আপোনালোকে জানে যে 1 ঘণ্টা 15 মিনিট আমি পিছ পৰি আছো। গতিকে এই সম্পৰ্কে মই সচেতন, গতিকে মই চেষ্টা কৰিম যে অতি কম সময়ৰ ভিতৰত যাতে মই মূল বিষয়টোৰ ওপৰত কিছু চৰ্চা আগবঢ়াব খোজো। তাৰ আগতে এটা কথা মই পৰিষ্কাৰ কৰিব খোজো। I am basically a teacher. I have been in teaching for last 40 years. This is the 40th year running in my teaching. আৰু এজন বিজ্ঞানৰ শিক্ষক হিচাপে বিজ্ঞানৰ সাধনা আৰু বিজ্ঞানৰ চৰ্চাত জড়িত হৈ আছে। আৰু সাধাৰণতে অকমান অন্তৰংগ আলাপ ছাত্ৰ ছাত্ৰীসকলৰ কৰি বেছি ভাল পাওঁ। এনেকুৱা সভাঘৰত বক্তৃতা দিয়াতকৈ 3জন বা 5জন ব্যক্তিও যদি সন্মুখত বহি থাকে, এটা বন্ধ কোঠাৰ ভিতৰত আন্তৰিক আলোচনা কৰি বেছি ভাল পাওঁ। এই কথাটো মই আগতে কৈ থৈছো। গতিকে এনেকুৱা ধৰণৰ পৰিৱেশত সভামুখী এটা ব্যৱস্থা আমাৰ বিজ্ঞানৰ যিখিনি বক্তব্য সেইখিনি ৰখাত কিছু অসুবিধা আহি পৰে, কিছু সীমাবদ্ধতা আহি পৰে। So there are certain limitations. I failed to address one of my most favorite students, and I take my pride in telling them he was my student, Dr. Sahabuddin Ahmed. গতিকে মই যিমান কম সময়ত পাৰো অসমীয়া আৰু ইংৰাজী দুটা ভাষা ব্যৱহাৰ কৰি কিছু কথা আলোচনা কৰিম, য'ত এই গোটেই সেমিনাৰখনৰ যিটো মূল বক্তব্য সেইটোৰ ওপৰত কিছু মই তথ্য আপোনালোকৰ আগত দাঙি ধৰিম। কেনেধৰণে আলোচনা সমগ্ৰ বিশ্বজুৰি এপ্লাইড বায়লজি ক্ষেত্ৰখনত ব্যৱহাৰিক জীৱবিজ্ঞানৰ ক্ষেত্ৰখনত হৈ আছে। ব্যৱহাৰিক জীৱবিজ্ঞান বা আমি কওঁ প্ৰাৰম্ভিক জীৱবিজ্ঞান, এই প্ৰাৰম্ভিক জীৱবিজ্ঞানৰ কি ধাৰণা এতিয়া বৰ্তমান চলি আছে এই বিষয়ত কিছু আলোকপাত কৰিবলৈ মই চেষ্টা কৰিম। Next. So my deliberations will cover an introduction to applied biology, latest advancement in the field in different areas, and the latest edition of artificial intelligence and machine learning tools in applied biology. And also I shall discuss about the fiscal prospect and challenges that are coming in the advancements of applied biology. Next. So if we want to define the applied biology is a multidisciplinary approach which encompasses various applied disciplines of biology, or mostly it bridges different branches of biology, particularly focusing on microbiology, genetics, and biochemistry. These are the focus areas in applied biology. কিন্তু আমি যদি চাওঁ যে বৰ্তমানে এপ্লাইড বায়োলজিৰ পৰিসৰ ইমানেই বিস্তৃত পৰিসৰ যে বিজ্ঞানৰ বিভিন্ন ক্ষেত্ৰত ইয়াক এতিয়া প্ৰয়োগ কৰা হৈছে। মই ইয়াৰ পিছৰ স্লাইডখনলৈ যাম কি কোন কোন ক্ষেত্ৰত প্ৰায়োগিক জীৱবিজ্ঞানৰ প্ৰয়োজন আছে। কিন্তু এই আমাৰ যিটো প্ৰায়োগিক জীৱবিজ্ঞানৰ প্ৰগতি, সেই প্ৰগতিত কিছু কিন্তু হেঙাৰ আমাৰ এতিয়াও আছে। বহুবিলাক কথা আমাৰ সকলোৰে কাৰণে নতুন নন আৱিষ্কাৰেৰে বিজ্ঞানীসকলে বিভিন্ন কথা পোহৰলৈ আনিছে, বিভিন্ন তথা প্ৰযুক্তিৰ আৱিষ্কাৰ হৈছে, কিন্তু সেই প্ৰযুক্তিসমূহৰ প্ৰয়োগৰ কাৰণে দক্ষতা বৃদ্ধি প্ৰয়োজনীয়তা সেইটো যদি আমি চকু দিওঁ আমি দেখা পাওঁ যে এই বিভিন্ন প্ৰযুক্তিবিলাকৰ যে আনুষংগিক পৰিকাঠামো বা ব্যৱস্থা বা ইনফ্ৰাষ্ট্ৰাকচাৰ দৰকাৰ সেইটো অভাৱৰ কাৰণে দক্ষতা বৃদ্ধিৰ ক্ষেত্ৰত কিছু আমাৰ প্ৰতিবন্ধকতা আৰু প্ৰত্যাহ্বান আহি পৰিছে, বিশেষকৈ আমাৰ উন্নয়নশীল দেশবিলাকত। In the third world countries where we are already in the developing process, we do not have the necessary infrastructure for technology application, training, and demonstration. That's why the progress is very, very slow. This is a big challenge for the third world countries like India. But even then, আমি ভাৰতবৰ্ষৰে অগ্ৰগতি লাভ কৰিব পৰা নাই, এই কথা আমি ক'ব নোৱাৰো। সীমিত ব্যৱস্থাৰ মাজতো বিজ্ঞানীসকলে এই প্ৰচেষ্টা অব্যাহত ৰাখিছে আৰু ইতিমধ্যে বিভিন্ন ক্ষেত্ৰত সেই বিষয়ে মোৰ পূৰ্বৱৰ্তী বক্তা ডক্টৰ চাহাবুদ্দিন আহমেদে কিছু কথা ইতিমধ্যে আপোনালোকৰ আগত দাঙি ধৰিছে। নেক্সট, মই আগতে কৈছো যে এইটো এটা মাল্টিডিসিপ্লিনাৰী চিষ্টেম। Applied biology itself is a multidisciplinary approach in biology. It can cater to the need of various branches of biology. Its application is vast in different areas of biology. These are some of the areas, but not exclusive. There are many other areas which might not have been mentioned here. Agriculture, veterinary science, marine biology, horticulture, sericulture, pisciculture, molecular biology, biotechnology, bioengineering, nuclear biology, space biology, exobiology, bioinformatics, biometrics, and overall all these in the health and pharmaceutical science. Next. Now, some of the advancements that have taken place in the recent era, particularly during the last 2 decades, have given very high level impact on advancement of applied biology. One of such epoch-making discovery came in 2012, the latest genome editing tool, what we have known as CRISPR-Cas technology. Some of my previous speakers, particularly Dr. Janapati Deka, your Vice Chancellor, has already mentioned about CRISPR-Cas9 technology. But the CRISPR-Cas technology is now not limited to Cas9 alone. There are many CRISPR-associated enzymes that have been identified, and they have made the sequence editing very, very easy. মই ছাত্ৰ-ছাত্ৰীসকলক এই কথাটো অকমান ক'ব খুজিছো, CRISPR-Cas technology বা genome editing technology বিস্তাৰ কৰাৰ আগতে আমাৰ হাতত যে তেনেকুৱা কোনো টুল নাছিল, এনেকুৱা কথা নহয়। 1990 দশকটোতে ইতিমধ্যে টেলেন বা টেল আৰু জিংক ফিংগাৰ নিউক্লিয়েজ এই এনজাইম সিস্টেম, নিউক্লিয়েজ মানে এইবিলাক কিছুমান উৎসেচক পদাৰ্থ অসমীয়াত ক'লে উৎসেচক এনজাইম যিবিলাকে নিউক্লিক এচিড বা ডিএনএ বা আৰএনএ ভাঙি দিব পাৰে কাটি দিব পাৰে সেইকাৰণে নিউক্লিয়েজ বুলি কওঁ নিউক্লিক এচিডক ই বিভাজিত কৰিব পাৰে এনেকুৱা এনজাইমৰ জৰিয়তে ইতিমধ্যে চেষ্টা কৰি থকা হৈছিল CRISPR-Cas9 টেকনলজিটোৰ আৱিষ্কাৰ আচলতে এটা accidental discovery, a sort of accidental discovery you can say. CRISPR-Cas9 is a natural system of nuclei. Bacteria বিলাকৰ গাত এই CRISPR-Cas natural এটা defense system হিচাপে সকলো সময়তে থাকে it is a natural defense system in bacteria as you know bacteria are very small unicellular microorganisms but they also suffer from disease বেমাৰৰ পৰা সিহঁতিও ভোগে মই ভাবো এইটো দৰকাৰী নাই বেমাৰৰ পৰা তেওঁলোকো মুক্ত নহয় বেক্টেৰিয়াৰ গাতো ভাইৰাছে বেমাৰ কৰিব পাৰে আনকি এনেকুৱা ডেলোভিব্ৰিঅ বুলি এবিধ বেক্টেৰিয়া আছে এই বেক্টেৰিয়াৰ আন বেক্টেৰিয়াৰ গাতো বেমাৰ কৰে বেক্টেৰিয়াক বেমাৰ কৰি পেলাই মাৰি পেলাব এতিয়াও বেক্টেৰিয়াও আছে এতিয়া বেক্টেৰিয়াই ভাইৰাছৰ পৰা পৰিত্ৰাণ পাবৰ কাৰণে যেতিয়া ভাইৰাল নিউক্লিক এচিড ডিএনএ বা আৰএনএ বেক্টেৰিয়াত প্ৰৱেশ কৰে তেতিয়া তাক এটেক কৰি ডেষ্ট্ৰয় কৰি পেলাই ভাঙি পেলাই আৰু সেই কামটো কৰে তেওঁলোকৰ নেচাৰেল মেকানিজম যদি CRISPR-Cas টেকনলজি আছে ইনহেৰেণ্ট ইন বেক্টেৰিয়া সেইটোৰ জৰিয়তে এইটো তেতিয়া আৱিষ্কাৰ হ'ল 2012 চনত ইয়াক এতিয়া বেক্টেৰিয়াৰ পৰা উলিয়াই আমি অন্যান্য কোষৰ ক্ষেত্ৰত প্ৰয়োগ কৰি দেখা গ'ল যে ই এটা নিৰ্দিষ্ট লক্ষ্যত নিউক্লিক এচিডত থকা বিশেষ অঞ্চলত বৰ্তি থকা নিউক্লিওটাইড বিলাকক এটেক কৰি তাক প্ৰয়োজন মতে কাটি পেলাব আমি সকলোৱে নিউক্লিক এচিড বিলাক গঠিত হয় নিউক্লিওটাইডৰ জৰিয়তে নিউক্লিওটাইড গঠিত হয় নিউক্লিওসাইডৰ জৰিয়তে আৰু নিউক্লিওসাইড গঠিত হয় দুটা বস্তুৰে এটা আমি কওঁ নাইট্ৰোজেনাছ বেছ এটা ৰিং ষ্ট্ৰাকচাৰ নাইট্ৰোজেনাছ বেছ এটা থাকে আৰু তাৰ সাথে সংযুক্ত হয় এটা পেন্টোজ সুগাৰ পাঁচটা কাৰ্বন এটম থকা এটা শৰ্কৰা জাতীয় বস্তু এই দুটা যেতিয়া ইউনিয়ন হয় তেতিয়া হয় নিউক্লিওসাইড তাৰপিছত তাত ওচৰাওচৰিকৈ থকা নিউক্লিওসাইড বিলাক যেতিয়া পুনৰ সংযুক্ত হয় ফসফৰাছ মলিকিউল ফসফৰিক এচিডৰ লগত বিক্ৰিয়া কৰি ফসফৰাছ মলিকিউলেৰে যেতিয়া সিহঁতে সংযুক্ত হয় তেতিয়া নিউক্লিওসাইডৰ পৰা নিউক্লিওটাইড আৰু নিউক্লিওটাইড বিলাক এটা শৃংখলাবদ্ধভাৱে যেতিয়া এটা শৃংখল বা এটা চেইনৰ তৈয়াৰ কৰে সেইটো নিউক্লিক এচিড আমাৰ দেহত থকা সকলো চাৰিত্ৰিক যিবিলাক গুণ structural and functional property of any living system depends on the code or the information that is carried by the sequence of nucleotide present in the genome of the cell that is present in the nucleus. I think as students of biology, all of you are aware of that. Etia, ami jano je ei je sequence of nucleotide, এইটো এটা নিৰ্দিষ্ট পৰ্যায়ত থাকিলে আমি সুস্থভাৱে জীয়াই থাকিব পাৰোঁ তাৰ নিৰ্দিষ্ট শৃংখল যদি কিবা কাৰণত অদল হয় এটা নিউক্লিওটাইড যদি সলনি হয় তাৰ ফলত বেমাৰৰ সৃষ্টি হ'ব পাৰে তাৰ এটা উদাহৰণ সিকেল সেল এনিমিয়া তোমরা শুনিছা সিকেল সেল এনিমিয়া নামৰ এটা বেমাৰ আছে যিটো কাৰণ মাত্ৰ বেমাৰ আছে যিবিলাক নিউক্লিওটাইডৰ পৰিৱৰ্তনৰ সৃষ্টি হয় particularly which are inherent diseases that means inherent or genetic disorders এতিয়া দেখা যাচ্ছে বহুতবিলাক বেমাৰ genetically inherit কৰিব পাৰে including some type of cancer গতিকে acquired disease থাকে একেবাৰে যদি IVF in vitro fertilization technology আমি টেস্ট টিউব বেবি আজিকালি টেস্ট টিউব বেবিৰ ব্যৱস্থাটো যথেষ্ট উপলব্ধ আমাৰ গুৱাহাটীতে মাত্ৰ 10খন মান কিজানি IVF ক্লিনিক আছে আৰু মই কৈ পেলাই গৌৰৱ অনুভৱ কৰোঁ যে তাৰ বহুকেইখন ক্লিনিকত মোৰ ষ্টুডেণ্টে তাত কাম কৰি আছে এম্ব্ৰায়লজিষ্ট গুৱাহাটী মেডিকেল কলেজতো মোৰ দুগৰাকী ষ্টুডেণ্টে এম্ব্ৰায়লজিষ্ট কাম কৰি আছে গতিকে এই টেকনলজিবিলাক হ'ল তাৰ ফলত কি হ'ল আমি ভ্ৰূণৰ প্ৰথম পৰ্যায়তে আমি ভ্ৰূণৰ যদি কিবা এনেকুৱা ধৰণৰ নিউক্লিওটাইডৰ শৃংখলটো দেখা পাওঁ তেনে তাক আমি তাক কাৰেকশ্যন কৰি দিব পাৰোঁ এডিটিং কৰি নিউক্লিঅটাইড তাত প্ৰতিস্থাপন কৰিব পৰা যায় বা যদি এডিশ্যনেল নিউক্লিঅটাইড তাত গঠিত হৈ আছে তাক আমি আঁতৰাই দিওঁ we can remove we can edit we can replace the nucleotides from the sequence and that's called genome editing or gene editing or dikoli akana now tantaman previous slide the first commercial product of application of CRISPR-Cas technology has come in the way of a soybean or ক্ষেত্ৰত এটা কৰা হ'ল কি লিনোলিক এসিড সাধাৰণতে সোয়াবিনত বেছি থাকে এই কাৰণ লিনোলিক এসিডটো আমাৰ স্বাস্থ্যৰ কাৰণে বেয়া লিনোলিক এসিডক যদি অলিক এসিডলৈ পৰিৱৰ্তন কৰিব পৰা যায় তেতিয়াহ'লে স্বাস্থ্যৰ কাৰণে ক্ষতিকাৰক নহয় গতিকে এনেকুৱা এবিধ সোয়াবিনৰ সৃষ্টি কৰা হ'ল এতিয়া য'ত লিনোলিক এসিডৰ সলনি অলিক এসিড প্ৰডিউচ এইটো প্ৰথমবাৰৰ কাৰণে কমাৰ্চিয়েল প্ৰডাক্ট হিচাপে ইউএছৰ মাৰ্কেটত আহিল আৰু এতিয়া সৰ্বজন বিদিত নেক্সট মই আগতে কৈছো যে there are a lot of advancements taking place to the basic CRISPR-Cas technology today. A lot of advancements have taken place, and next generation technologies like prime editing and base editing has come, and FDA, who have administration of government of USA, have already approved the application of these technologies, particularly in case of sickle cell anemia, sickle cell disease, chimeric antigen receptor T-cell therapy or RT-cell therapy for treatment of cancer. এইবিলাক বিষয় ইতিমধ্যে commercially available gene editing technology আহি গৈছে next please one example দিব কৈছো a success story of the CAR T-cell therapy the first patient who was treated in 2024 by use of artificial therapy. So her name was Elisa. Her parents were almost fed up by getting treated her with waste of medicines against the type of cancer she was carrying. There is a T-cell acute lymphoblastic leukemia. It's a blood cancer. But she was taken to many different hospitals, including the Scripps Hospital of California, but she could not be treated. Finally, the doctors have already declared that so to say destined death of the particular child. Then they approached the Scripps laboratory molecular biologists who have already developed the technology and used it in mouse to showcase the use of the CAR T-cell therapy for treatment of cancer. Her parents volunteered to that means utilize that technology for the treatment of the child. And she was treated by this technique. And now, after around 13 months of her treatment by CAR T-cell therapy, she is still completely healthy without any sign and symptom of cancer. She has been totally rid of cancer, and it is a first success story of complete recovery from cancer by CAR T-cell therapy. What is done in CAR T-cell therapy actually? It's an immunotherapy. In this particular therapy, the scientists used to take out the cytotoxic T cells of the body of the patient. Amar dehot kisuman blood vessel or ভিতৰত বিভিন্ন ধৰণৰ কোষ থাকে তোমালোকে জানা নিশ্চয় তাৰ ভিতৰে কিছুমান আমি লিম্ফোসাইট বুলি সেই লিম্ফোসাইট বিলাকৰো আকৌ বহুত বেলেগ বেলেগ ভাগ আছে তাৰে এক ধৰণৰ লিম্ফোসাইটক কোৱা হয় টি সেল এক ধৰণৰ লিম্ফোসাইটক কোৱা হয় বি সেল এই টি সেল যেটো থাকে টি সেলৰো আকৌ বহুত ভেৰাইটি আছে টি সেলৰ এটা ভেৰাইটি হ'ল সাইটোটক্সিক টি সেল or what we refer to as CD8 cell আৰু এবিধ আছে CD4 সেল যেটো আমি হেল্পাৰ সেল এতিয়া CD8 সেল বিলাক কেতৰ কাম হ'ল কি যদি বাহিৰৰ পৰা কোনোবা যিকোনো সেল কিয়তি ডেষ্ট্ৰয় কৰি দিব পুলিয়াই ধ্বংস কৰি পেলাব পাৰে ই লাগে ব্যাকটেৰিয়াৰ সেলেই হওক বা অন্যান্য প্ৰাণীৰ পৰা হওক সেলেই সকলো কোষকে ধ্বংস কৰি পেলাব পাৰে টাৰ্গেট ঠিক তেনেকৈ কেঞ্চাৰ সেলবিলাকো ধ্বংস কৰি পেলাব কিন্তু এটা কেঞ্চাৰ পেচেণ্টক এই যুদ্ধখনত সাধাৰণতে টি সেলবিলাক হাৰি যায় টি সেলবিলাকে যিমানখিনি কেঞ্চাৰ সেল আছে সব মাৰি পেলাব নোৱাৰে হাৰি যায় সেই যুদ্ধখনত হৰাৰ কাৰণেই কেঞ্চাৰ হয় Now, in this technology, what is done? All T cells are acquired from the patient. They are subjected to the gene editing technology, CRISPR-Cas9 technology, so that their T cells are modified. Two modifications are essential, most commonly done. One is to provide them an additional gene which will code for production of a protein receptor on the surface of the T cell, which will specifically recognize the surface antigens of the cancer cells. Third, এই surface of উপৰিভাগত এনেকুৱা ধৰণৰ কিছুমান প্ৰটিনৰ সৃষ্টি কৰি দিয়ে যি প্ৰটিনবিলাকে বাছি বাছি কেঞ্চাৰ চেলবিলাক আইডেন্টিফাই কৰিব পাৰে আৰু সিহঁতৰ লগত সংযোজিত আৰু মডিফিকেশ্যন কৰা হয় সেই মডিফিকেশ্যনৰ জৰিয়তে এই সিগনেট মাৰ্কাৰবিলাক আছিলে সাইটোটক্সিক টি সেল মাৰ্ক অৰ্থাৎ বডিয়ে চিনি পাই যাৰ জৰিয়তে দেখিলে অন্য সেল ধ্বংস কৰিব পাৰে সেইকাৰণে কেতিয়াবা সাইটোটক্সিক টি সেল বাহিৰৰ পৰা সোমাই দিয়াৰ লগে লগে ইমিউন সিস্টেমে আকৌ সাইটোটক্সিক টি সেলবিলাক ধ্বংস কৰিব নোৱাৰাৰ সম্ভাৱনা থাকে সিহঁতক ধ্বংস কৰিব নোৱাৰাকে আৰু মডিফিকেশ্যন কৰি দিয়া হয় এই টি সেলবিলাকক জিন এডিটিঙৰ জৰিয়তে তাৰপিছত সেই যিখিনি মডিফাইড টি সেল সেইখিনি আকৌ পেচেণ্টৰ ব্লাড ভেছেলত ভৰাই দিয়া হয় ইনজেকশ্যন দি ডায়ালাইসিস যেনেকৈ কৰে তেনেকৈ আকৌ ভৰাই দিয়াৰ পিছত এই যিখিনি মডিফাইড টি সেল সিহঁতে বাছি গোটেই দেহত 4 পৰা 6 সপ্তাহৰ ভিতৰত যিমানবিলাক কেঞ্চাৰ সেল আছে সবক এটেক কৰি মাৰি দিয়ে কম সময়ৰ ভিতৰতে গোটেই কেঞ্চাৰ সেলবিলাক দেহৰ পৰা নাইকিয়া আৰু কিন্তু ironically, unfortunately, till now, we have to spend millions of dollars. The first patient have to spend $200 million for treatment. It's a very, very expensive treatment as of today, although the technology is already existing. I think days will come when the cost will be reduced to a great extent. I'll tell you a story for that, how cost is reducing. You know about the sequencing of DNA. I think our understanding of molecular biology is centered around the understanding of the sequencing. How the sequence of nucleotides present in the gene or the genome is determined. So the latest technology is called NGS, Next Generation Sequencing Technology. The first technology of its kind was developed in 1977 by Frederick. Can anybody help me? Frederick Sanger, yeah. It is called Sanger sequencing technology. So in Sanger sequencing technology, only 1 or 2 genes at a time can be sequenced. The long sequence of DNA in the genome cannot be sequenced at once. When the Human Genome Project was started in 1990, there was only Sanger sequencing available. So 20 international group of scientists from across the globe, they joined hands together and they decided to sequence the entire genome of only single individual human being. Because the technology was not there, that's why they targeted to complete the work in 15 years. And the cost outlay was $3 billion. That was given by US government. $3 billion. But fortunately enough, there have been a lot of work going on simultaneously in other levels. And by 1998, first draft human genome came to the fore. And that was not done by this group. That was done by another group of scientists from a private company called Celera. They were also doing simultaneously. Nobody knew about it. Then after that, both these groups joined hands together and they completed the task in 13 years. In 2003 April, for the first time, 1 human genome was sequenced, and the cost was $3 billion. It took 13 years, but you will be surprised to know that in 2009, Steve Jobs, the Apple man, the owner of the Apple computers, he suffered from cancer, and he volunteered to pay any money to any scientist who can sequence his genome and find out where is the fault. Then you will be surprised to know from $3 billion, the price has come down to $5 million US in 2009, only after 6 years. And the time required was only 10 months. From 13 years, it reduced to 10 months. You will be more surprised to know that in 2012, another big company called Pacific Bioscience have developed the first NGS machine of high capacity that is called PAC biosystem. And that can give rise to one individual human genome in 3 days, less than 3 days, and one bacterial genome in 1 hour to 3 hours. So now if you send bacterial samples to some of the advanced laboratories for sequencing in bulk, then it will cost only around $60 to $70. And if you send a human genome sample, it will cost you around $500 US if you send in bulk. So from 3 billion to 500, it has come. So we can wait and see. The CAR-T technology, CAR-T cell technology is also coming to get reduced in its price in next few years. Same thing is happening in case of test tube IVF. How costly it was at one time. Now you can have it in paying on it. If you want it in itself. Next please. Now gene therapy is another important aspect which has also advanced the applied biology field to a greater extent. I will not go in detail, but what is gene therapy to tell you in brief. Here কি হয় যে বাহিৰৰ পৰা কিবা character এটা চৰিত্ৰ বা এটা গঠন যদি আমি এজন মানুহ বা অন্যান্য জীৱ বা পাত্ৰৰ গাত সোমাই দিব লাগে তেতিয়াহ'লে আমি জিন ইনজেক্ট কৰিব ডিএনএ ইনজেক্ট কৰি পেলাই যিকোনো এটা অৰ্গেনিজমৰ character চেঞ্জ কৰিব পৰা যায় ষ্ট্ৰাকচাৰ চেঞ্জ কৰিব পাৰোঁ যাকে কয় জিন থেৰাপি মই ডিটেইললি নাযাওঁ because lack of time. It has been already used in medical applications for correcting many of the inherited congenital diseases and also for treatment of hepatitis B, treatment of HIV, and also for various kinds of infectious diseases. Similarly, this technology has also been used in crop enhancement in agriculture. It is also used in bioremediation. That means the cleaning the environment. Next please. Then comes the application of artificial intelligence and machine learning. I think people have already visualized the artificial intelligence and machine learning, including IoT, as the technology for the future. And it is expected that it will change the face of all the different technologies existing today. Because more automation will come, more accuracy will come, and more robust manipulation of the biological system will be possible through AI. This is the expectation, but it has to go a long way to serve the humanity in the expected way. Now it is under trial in different systems, but AI is coming up in a big way in different branches of biology. Now some wearable devices are available connected to computer which can detect animal and human diseases. So even in animals, the bands are fitted to the legs of the animals. And those bands are having the particular kind of, so to say, sensors. The sensors will read many different parameters of the health of the particular animal, including the temperature, pressure, movement, then other characteristics, and that will give signal to the computer. And by application of artificial intelligence and machine learning, computer will analyze the data, comparing with known standards already existing, and then they will interpret in terms of the detection of the disease, what disease is coming. So if you come to our laboratory, in our institute itself, in College of Veterinary Science, Kanapura, we have recently launched a program of in vitro fertilization in cow. And for that, a huge grant has been received from Government of India to the tune of 29 crores. We are already establishing one milk parlor, sophisticated milk parlor, supported by AI. Now, when the animals will be taken to the main part of milking by machine milking, when they pass on through the particular gate, all the parameters will be automatically recorded. And then the person sitting in the computer can immediately detect if one of the cows are having temperature. If one of the cows is having some health issues, that will be recorded by the computer immediately. Then immediately that cow can be taken out and she will not be milked. So if you come sometime, you will be surprised to say that kind of technology is existing everywhere. It can be installed here, very costly. So there are different technologies where artificial intelligence can help us in not only detecting diseases, but also for developing devices which can be used in agriculture, which can be used for bioremediation, which can be used for space research, and many other areas. Next, please. Now, synthetic biology is one area where much emphasis has been given recently. So, synthesis has taken place to a great extent, not only in terms of the production of the biomanufacturing products like bioethanol. I think you know that only yesterday our Honorable Prime Minister had inaugurated world's first bioethanol project from bamboo in Inaugural refinery. This is the world's #1 project. So where millions of tons of bioethanol will be produced every month. So that kind of technology is coming in a big way, where the cells of the biological system can not only be used for resource material for production of industrial byproducts, but at the same time, many biological systems can be now used as a bioreactor for producing different kinds of products. The chicken bird can be used as a bioreactor for producing different therapeutic products useful for human beings. That has already come to the market, and in India, I'm happy to share with you that one project has been already funded by NASF, National Agricultural Science Foundation, where I was a member for 6 years as a reviewer, and we have already funded one project of 3.5 crores to a scientist in Hyderabad, who is also replicating that technology in India. Some bioproducts will be generated by chicken, which will be useful for treatment of thalassemia and hemophilia, some very, very important diseases of human beings. Next, please. So synthetic biology has reached its, so to say, the galore and the kind of advancement in the recent past, to the extent that now the entire genome of an organism, the nuclear material, entire DNA of its organism can be synthesized in the laboratory based on pure chemistry. A chemist can now synthesize the entire genome of a living thing. I think all of you should know that the first gene synthesis, artificial synthesis of a gene, was carried out for the first time in the world by an India-born scientist. The name was Dr. Haragubin Khurana. Although we could not keep him as Indian because he already took citizenship of US, but he is an India-born scientist. He was the first person to synthesize the genes in the lab. Now, gene synthesis is very popular and common. I think you know, all of you know about the polymerase chain reaction, the PCR technique, the diagnostic technique and research technique, which also needs some synthesis of DNA, what is called primer. In US, if you are in a research laboratory, if you design a primer and give order to the laboratory for synthesis of the primer, I was in University of California, I was surprised at the beginning. When I gave order for the primer at 10 a.m. in the morning, the synthetic primers were ready for use at 2 p.m. in the afternoon. In 4 to 5 years, they synthesize. But in our case, even now, it takes a 1 week time. You have to wait. But that is a big discovery. And now, not only genes, the genome can be synthesized by chemical process. The success came first in 2010. A publication was done by the student of Dr. J. Craig Venter, but final demonstration could be done only in the year 2012. So he himself named this technology as synthetic genomics, and he has also established one company in the name of synthetic genomics, and he patented the technology. Dr. J. Craig Venter Institute has been established in Rockville in USA. He was a Canada-born scientist, but he shifted to California. Now he is in California. So it is a great contribution. With this, I'll end my lecture. So I'll briefly describe what is done. You'll be surprised to know how it is done. You know, as I said, that bacteria do have nuclear material DNA as that of any other higher animals or plants. But the bacterial DNA, as expected, is a short genome because human beings are so to say, complex organisms. We do have so many characteristics. We need around 23,000 genes for our structure and function. Functional genes are around 23,000. But there are some bacteria which are very small unicellular organisms. They do have only few hundreds of genes. Mostly they do have around 700 to 1200 numbers of genes in bacteria. And out of all bacteria, one particular group called mycoplasma, they are cell-wall-less forms of bacteria. They are very small, and their genome size is also very small, only 1.63 megabase. Our total DNA length is 3,300 megabase, but their length is only 1.63 megabase. It is a small genome. So what we did, Dr. Craig Venter studied the entire genome of two mycoplasma. One is Mycoplasma mycoides, another is Mycoplasma capricola. The first one causes pneumonia in humans, particularly in children, and the second one causes pneumonia in calf and cow, as well as in case of goats. So he studied the entire genome of the Mycoplasma mycoides and found that it contains only 167 essential genes. What is essential gene? These are the genes, the product of which will be essential for survival of the organism. Without that, they cannot live. But there are many other things which will produce certain products or proteins which may not be necessary for survival. So he identified the 167 genes which are essential. Then he sequenced a sequence diagram in a computer. And after eliminating the non-essential part, he reassembled only the essential 167 genes into a circular genome by using computer. He designed it by using computer. And then computer diagram or the design was given to a chemist for synthesis of the genome. At the same time, what he did, he took the another culture, Mycoplasma capricola. From there, he enucleated the cells. Enucleation means taking out the nucleus. So that can be done by various processes. One process is easy by using a micro injection. Okay, that can be done with micro manipulator. You come to my laboratory, we have got the machine micro manipulator. They're very costly, 29 lakhs. So you can insert a small needle, just say this, into the cell, individual cell, and you can take out by suctioning. You can take out the nuclear material. So by this way, he enucleated the Mycoplasma. Then he took the chemically synthesized genome of Mycoplasma mycoides, having only 167 genes, and reintroduced that synthetic genome into the Mycoplasma capricola by micromanipulation. To his utter surprise and to the surprise of the entire world, the bacteria, after inoculation with the artificial genome, not only survived, but they also started growing. And within one night, overnight, it produced millions of progeny, like that of normal bacteria. So this was the first story of successful implementation of the synthetic genomics technology. So that means, what do we expect? After the nucleus of Mycoplasma capricola is replaced by a synthetic genome of Mycoplasma mycoides, all the cells have become Mycoplasma mycoides. Means the species has been totally changed. From one species, the bacteria has become another species. So not only a single gene can be changed now by editing or other techniques, but now we can change the entire genome of the cell. And he has already described another technology, hypothetically. He said biological teleportation is possible. And very nice and very interesting story. He tells that if sometimes human beings can come across some small microorganism in the extraterrestrial space somewhere, in some other planet or somewhere, then we need not worry about bringing that organism to Earth. We can get a sketch of the genome only with the help of our space shuttle. And that picture is sufficient for us to design the entire genome using computer, and we can synthesize the genome, and we can recreate the organism on Earth without bringing it up. At least at this point of time, we can say that it is possible in case of bacteria, if not in case of eukaryotes. But now the work is going on is the unicellular fungus. So they will come when similar technology will be available for use in plants, use in animals as well as in human. And again, for discovery. And after he established the particular industry, synthetic genomics, now in interest we find that he has already got a contract of $600 billion from two famous pharmaceutical companies of the world to produce some humanized protein products which are useful for therapy. Say, for example, hemophilia, you know, Dr. Sarma is with the knowledge of that. Hemophilia is a disease which is inherited in nature, and the royal family of London suffers from, particularly male individuals suffer from hemophilia. It is a sex-related inheritance. Only males people suffer. And there, the deficiency of factor X or factor 10 of coagulation of blood. Coagulation of blood requires 18 different enzymes and proteins. If there is a deficiency of one of them, the blood cannot form. So, factor 10 or factor X, what we call, that is very important in the coagulation process. If there is a deficiency, then blood cannot form. So, hemophilic patients will, when they suffer from simple injury, bleeding will continuously take place and they will die. So, they want to have factor X therapeutic. That is now being produced by using goats, by transgenic goats is being produced in milk of goat. But that will be very rare if it is produced by synthetic genomics by using bacteria. I think, you know, internationally, human being kind of insulin that was used for diabetes mellitus treatment. Although many of us may be having some misgivings or misbeliefs about the use of GMOs, genetically modified organisms, but we are all using that particular medicine, the humulin, that is being manufactured by only bacteria now, which is a genetically modified organism. The human insulin gene has been introduced into bacteria, and bacteria is producing humans. So the day will come, that kind of technology will be available in India also, and we look forward to see those developments in our life. Let us all hope that we will see this in our life. With this, I conclude my speech. Thank you very much. Next, please. I'll skip some of the slides. Fine. Oh. Thank you very much. If some of you are having some queries, particularly students, I'll be more than glad to answer. No, it will be used for any other type of cancer later on, which are inherited cancer. To one at this moment, it has been used for cancer. It will again successful. In the future, it will be used for other types. I have skipped some of the development advancements because of lack of time. 3D bioprinting, 4D bioprinting, then microbial analysis to the level of the microbiome analysis. All these are coming up in a big way. I avoid it.
তেতিয়া আমাৰ ইয়াতে বহুত বিকল লাম্পিক স্কিন ডিজিজটো হয় গতিকে তেনেকুৱা ক্ষেত্ৰত কাৰণে আপোনালোকৰ
lumpy skin disease is a viral disease, but particularly in case of cat and buffalo. And success story of India is that the Indian Veterinary Research Institute has already commercialized one indigenous vaccine in the last 3 months, 3 months before. It has been launched commercially, a successful vaccine created in India. Already it is available. But of course, lumpy skin disease vaccine was already available earlier, but not in the form of the lumpy skin disease vaccine, but the similar kind of goat pox. Like it's a pox virus of something disease. So goat pox immunogen or goat pox vaccine can also be used to protect animals against lumpy skin. So that has been already used in many countries of the world, even in India it was used. But now indigenously prepared specific vaccine is available. That is already produced by Indian Veterinary Research Institute. Any more questions?